Hello everyone, I hope you all are doing amazing. Now we will begin the Grade 12 Advanced Explanation videos for the end of term exam. I'll be covering each topic in a separate video. There are 25 topics in total. And before we begin the topic, I will just quickly go through the exam scheme. And this is the exam scheme for term 2. You will have part 1, part 2 and part 3. Part 1 and part 2, you can see there are different number of questions. Part 1 only 10 questions, part 2 it's 12 questions. And part 1 is just 3 mark questions, whereas part 2 is 4 to 5 marks. And part 3, it's all writing. You will be given a paper and you'll have to write everything in detail. You cannot directly write the answer. You need to solve each step, substitute, write the formulas if necessary, and then solve the problem. Whereas part 1 and part 2 is completely in computer and you will be given 4 MCQ options and you need to choose the correct one. Part 3 is the most highest marks per question, 6 to 7. And you have 2 bonus questions this time, and both the bonus questions will be in writing, that will be included in part 3. Each bonus question is of 5 marks, and these are all the topics. Some of the topics are repeated, but they might ask you a different concept altogether. Maybe the options might be different. Over here they might ask you critical points, maybe over here increasing, decreasing. Anyways, when we do the topics, you will come to know in detail. So all the 25 topics, known topics, I will make the revision videos. The last two can be anything. The bonus questions can be anything that was taught throughout the term in the regular classes. Now, one thing, these revision videos, I'll try to use the shortcuts for the first two parts, part 1 and part 2, where the MCQs are given. I won't go in detail and elaborate explanation because that was already done in class in your regular term. Now, I will just try to teach you the easiest or the simplest method how you can get the answers by spending as less time as possible. So I hope you all are ready, and if you find these videos helpful, I would really appreciate if you subscribe this channel, and I wish you all the best and happy learning. Now we move on to the first topic. The first topic is to find critical points of a given function. Now this is the function. To find critical points, there's a method. The first step is to derive this function, and next step is to equate whatever you derive to 0. Now, over here, derivation of this function would be f dash of x, that is derivation rule. 2x to the power 2 will become 2x to the power 1. The rule states this: whatever the power is there comes down and you need to reduce the power by 1. 2x, that's it. Power 1 will be x itself, plus 5. If it's only x to the power 1 or x, that will just become 1. And over here there is nothing, that means it's x to the power 0. When 0 comes down, this term goes. So whenever there is no x term, it's basically 0. So this is the derivative. Now what you need to do is equate this: f dash of x equal to 0. That means 2x plus 5 equals 0, and the answer would be 2x equals minus 5, x equals negative 5 by 2, or negative 2.5. So this is the answer over here. So that is the critical number, but they have also asked few other things over here. Use the knowledge of the type of graph, parabol or cubic, and determine whether the critical number represents local maximum or minimum. See, now over here, looking at the function, this is a parabola and it's plus over here, so it's opening upwards. So whatever the critical number is there, it will be the minimum point. So this will be having the minimum at x equals whatever we found out, that is minus 5 by 2. And the parabola open upwards. Whereas over here in the second problem, you can see it will open downwards and will have a maximum point. Whatever you solve will be maximum. So same method what we did, it will be opening downwards because there's minus sign over here before x squared, and that is the answer. Same way you can try solving others. Now over here it's cubic. So cubic is little hard because, if it is positive over here, it'll go like this. Okay. So now you will have two critical numbers over here. See, same method. You can solve this directly. Looking over here, derive it 3x squared minus 3, and then equate it to 0. Directly you can equate it to 0. It'll be 3x squared equals 3x squared equals 1. X is equal to plus or minus 1 because you have to take square root on both the sides. Now over here you will have two. See, if you go and graph a x cube function, you will come to know it's like this. They have told you having the knowledge of the graph, parabola and cubic. Now over here there are two points, critical points, that'll be over here and over here. So the left side one will be maximum. So whatever you get the left side, that will be lesser value. So in that plus 1 and minus 1 is lesser. So that is first over here. That will be maximum. And this over here will be minimum. X1 is local minimum. X is over here local maximum. Similarly, you can solve the others. Over here, there is just over here in the solutions from the which I had initially posted, there was an error of minus. Over here, it was taken as minus somewhere. Okay, over here, it was taken as x of minus 4. That is wrong. When you solve it, you will get two answers. X is 0 and plus 4. And then, as I told you just now, you can solve it. You can have the knowledge of the graph. Now over here it's minus, so what happens is the upside is the left side. The cubic graph will be something like this. So the first value, the lower value, which is the lower value? 0 will be a minimum and 4 will be a maximum. So this is how we can solve having the knowledge of the graph. But now, say some cases over here, if we solve over here, you won't have a real solution. See, because when you solve this, the roots are imaginary. See, because you're getting imagined roots, there is no critical points if they are imaginary, if you cannot solve. See, sometimes what happens is if you have something like this, minus 1, you have to take square root on both the sides and you realize it is imaginary roots and there is no critical points. And also you must know one more thing. Whenever you have just one point, say for example over here you solved all this, and how many critical numbers are there? There is only one critical number. Whenever there is only one critical number, you will never have a maximum or minimum. These are few things, because if you do in detailed graphing, that is finding the f dash of x, taking the critical number and testing the values for positive and negative, you will realize there won't be a critical maximum or minimum point. So what to remember over here? Whenever you have x to the power 3, you derive it, it'll be x to the power 2, and you must have two critical numbers. But in certain cases, you will have only one critical number. So now, which is this function? A cubic function. Cubic function with only one critical number is neither local nor maximum. So this is very important to remember. This will be neither local nor it will not be a local maximum or minimum. So this is neither, that is the solution. There is one critical number, that is neither. And now if it is x to the power 4, see, this is hard to remember. This will be similar to a parabola. It will be something like this. Okay, but it's still hard to remember. Now, honestly speaking, you may not be exactly 100% right on which is the top point and the bottom point. So in such cases, when you have x to the power 4, it will look like a parabola, like this shape. You can try it in the graphing calculators. Now, what you can do is, I will do a method over here. So first, you need to derive this. That will be x to the power 4x to the power 3 minus 4x. Okay, and then now you need to solve this. You can solve it in various methods. Now, one of the method would be by calculator, that is mod phi and then option number 4. And what do you get over here? You'll get 4. Sorry, you need to substitute the values first. 4 x squared is not there, so it's 0. And lastly, minus 4, and there is no number, so it's again 0. So the critical number x1 is 1, minus 1, and 0. We got three critical numbers. You can see over here the critical numbers are x minus 1, plus 1, and 0. Now, how do we know which is local maximum and minimum? If you have the knowledge of the graph, yes, it's possible, but still there is one more method. This is a standard method. You should know this because you need this knowledge in the coming problems. All you need to do is say the critical numbers are found out by the derivative, isn't it? Plot them. How do you plot them? Say now 0 is somewhere over here in the ascending order, minus 1 over here, and 1. So this equation, the derived equation, is important. Now you need to test some values. Okay, test some values. So let us take a value less than 0 but greater than minus 1. So it will be minus 0.5. Over here you need to take one more value. You can try with others. You can take 0.25. You'll get the same positive or negative value. That's at what we want. Then over here it's 1.5 minus 1.5. So what you need to do is, these are the test values. You need to put these values in this derived equation, not in the initial equation, the derived equation, and then check the value is greater than 0 or less than 0. We don't care about the value, we just care about it's positive or negative. So what we do is over here, now put over here 4. So mode 1, 4 bracket, because it's minus over here, minus 1.5 the whole cube, minus 4 into 1.5. Sorry, minus 1.5. That's it. The answer we got is negative. We don't mind whether it's 17.5 or anything. We just want minus or plus. So what I'll do is write over here minus signs. 1 is enough just for understanding. It's negative over here. Then I need to change to what? 0.5. Let me change the x values to 0.5. Okay, now I'm getting a positive value over here. Now again change it to positive 0.5. I'll change the negative sign. I'll remove the negative sign. And now again I got a negative sign. And then I will have to change to 1.5. So it's again a positive value. So what I am getting is positive when I put a test value less than negative 1. And over here also, sorry, negative over here, positive, negative, positive. What this says is the way the function is increasing and decreasing. So before the domain of x minus 1, the values are decreasing, so the graph will be going downwards. Then over here it's increasing, it will go upwards, then again down, and lastly again up. So now you can easily understand which is the local minimum and maximum. See, the graph is something like this, going up, going down, and then you know it is a parabola, so it will go up, and over here also it will go up. This is the shape of the graph. Now, which is the minimum point? It is minus 1. So you can see that not only minus 1, even plus 1. X of plus and minus 1 are local minimum, whereas this over here at 0 is maximum. That is how we find it out. And the last problem can be done same way, but over here when you do the same method, see, I will just show it over here. The critical points are 0 and 9.4. So 9 by 4 is about 2.25, and this is 0. So what happens is over here, you will have minus, I'm not sure, but you need to try this trial. Let's take, for example, minus 0.5, and we will just do this quickly. And over here, I'll take 1, and over here, I'll take 3. Okay. Now, let us try these values. We have to put in the derived equation, that is 4 multiplied by x, that is minus 0.5, the whole cube, minus 9 into minus 0.5 square. Okay, this is done. Now over here there is a important thing. Press equal to, over here it's minus, so now it's fine. Now the important thing is doing the same thing in the derived equation, because I still remember some of my students try to put it in f of x and they got the wrong answer. Don't put it over here, do it in the derived equation, because this is The critical numbers are from the derived f dash equation. Okay. Now try the next one. So the next one is 1. So I will just change it over here to 1 instead of x. 1 over here and 1 over here. So what is the answer I'm getting? It's minus. So again, I'm getting a minus. And last one, let's try 3. Now let's put 3 over here and 3 over here. And I'm getting a plus. So over here, it's plus. So what do you understand over here? This part, it's decreasing. Again, it's decreasing. Only over here, it's increasing. So the graph is something like this. Only at 9 by 4 it's increasing, so the critical value is only over here. See, this is a minimum. 9 by 4 is a local minimum. Why? Because it's decreasing. Whereas 0, no, it is neither maximum or minimum. Why? Because it does not change. Only if this changes, the sign changes, then you will have maximum, minimum. So if you have the knowledge of the graph, as we did for the first few problems, it's easy. But if you do not, it's very hard to understand this exactly. So it's better to do the method I just did, and then you can check the answers. Over here, detailed methods are there. You can see over here, it's directly from the knowledge of graph. But in the coming problems, coming topics, we will see the method again and again. So please make sure you understand the writing the critical numbers and testing the values. The second topic is again similar to what we just saw in the first video. Now we cannot do this properly if you have not seen the first video thoroughly. So please go back, watch the video one thoroughly, understand how we can graph the equations with the critical numbers and taking choosing some values, some test values and putting in the derived equation and then finding whether it's plus, minus and plus. And this is how we understand where the graph is going. Imagine this was increasing, decreasing and increasing, then we know the graph is something like this. We can understand which is maximum and minimum. So that is the thing. Over here, now they have asked to use graphing technology and they have asked you to find the critical numbers. So these two problems are just like what we had done in the last video. So please go back to the video and then try this solving yourself and check the answers over here. But now we will check this over here. Now see, these are a little complicated problem. Now the difference between this and the first topic is over here, you can't have the knowledge of graph because it's very difficult to know what graph this is exactly. So you need to try and solve it by yourself over here. Uh, Now let's do this one because this requires chain rule. You can see power and there are two functions, so it'll become a chain rule. How do we do chain rule? When we need to first derive this, find f dash of x. So f dash of x is equal to, here it will be 2 times x2 by 5, this power, minus 3x1 by 5. It'll be power 1, so I don't write that. Multiply with the derivative of this inside function. What is the inside function derivative? It'll be power rule over here, 2 by 5, x 2 by 5 minus 1. I'll directly write it'll be 3 by 5. So then minus 3 into 1 by 5, it'll be 3 by 5, x minus 4 by 5. So these are the two functions, that is for after deriving. Directly I've done derivation. Very simple. This is, if you're thorough with difference derivatives or differentiation, only then you can understand it easily. So you need to be thorough with differentiation first. Now, what would be the next thing? Over here, all you need to do is equate this to 0 to find the critical numbers. So how would you solve the critical numbers? Just equate it to 0. Now, since there are two, you're multiplying two terms, this will be equal to 0 and this will be equal to 0. It's like that. So that's how we solve the critical numbers. Now, first, either this will be equal to 0 or this will be equal to 0, isn't it? So let's equate this. X2 by 5 minus 3x1 by 5 equals 0. And let me solve it. Let me take this to the other side. It'll be x, sorry, let me over here. Now, x 2 by 5 equals, when I take minus to the other side, it'll be plus x 1 by 5. Now, all we need to do is take x to the other sides and equate it. So, what would I do? I will take it to the other side, x 2 by 5 divided by x 1 by 5, equated only with numbers now. Keep only one numbers over here. Now we know the exponent, when it goes up, it will become, the sign changes and it becomes minus. So x 2 by 5 minus 1 by 5 is equal to 3. And now what we do is we solve this. 2 by 5 minus 1 by 5 is 2 minus 1 is 1. So it is x 1 by 5 equals 3. But we need x value, not this 1 by 5. So raise this to the power 5 in order to cancel 1 by 5, but remember to raise both the sides. This is simple algebra what I'm doing over here, just cancelling, and the answer is x 3 by 5. This is one critical number. Same thing will be done over here. Now we have 2 by 5 x minus 3 by 5 minus 3 by 5 x minus 4 by 5, that is equal to 0. Now all I need to do is take this to the other side. So it will be 2 by 5 x minus 3 by 5 equals 3 by 5 x minus 4 by 5. Now we need to simplify this. Look at this, 5 cancels, and take the numbers to one side and the powers to the other side. So I will take this to the other side, it will go down. See, x minus 3 by 5 divided by x minus 4 by 5. And then what do you do? Over here it is 3 by 2 the whole power. Sorry, that's a 3 by 2. Now, take this up. The down power is negative. When it goes up, it'll be positive. So it'll be x minus 3 by 5 plus 4 by 5 equals 3 by 2 is 1.5. Let us keep it as 3 by 2 itself. And now when you solve this up, you will get x 1 by 5. Okay, why? Because minus 3 plus 4 is 1 and 1 by 5, that is equal to 3 by 2. Now again it's the same thing, raise both the sides to the power 5 over here and over here. Now what happens, just like over here, but over here it's only 3. Over here x is equal to 3 by 2 the whole power 5. So these are our two critical numbers. X is 3 by 5, x is 3 by 2 whole power 5. I am not sure whether you will get it in calculator, but still, let's just try it once. So I think so simply, let's try this one. Alpha x to the power 2 by 5, that is equal to 3 alpha, sorry, I need to take this out, now equals to 3 alpha x to the power 1 by 5. Now let's shift and solve. Okay, you're not getting the answer over here. So yeah, it's not possible then. Maybe some simplified form might be possible. I'm not sure. You can try it. Maybe, yeah, I've done everything correctly. Let me, yes, it's all right. So sometimes when it's very complicated equations like this, it's a 2 by 5 is basically 0.4. It's a small power. It may not work. So that's the thing. But anyways, this is how we solve it naturally in writing. Now, once you find this, you need to graph. So now let's just check our answers. It's 3 by 3 to the power 5 and it's 3 by 2 to the power 5. Okay, this is all right. Now how do we know which is maximum minimum? Basically we need to know the graph, but this is very complicated graph. We won't know in our mind directly. So what do we need to do is what we had done in the last video. Let's draw a straight line and then let's take the critical numbers. Say for example 3 to the power 5 is bigger than 3 by 2 the whole power 5. So then we will take test values. Now we need to know what is 3 power 5. It's a huge number, 250 or something. 243. Now 243 over here, we should take any value less than 243 and more than 243. And what about this? This is very small, 3 by 2. That's 1.5 to the power 5. That is 7.59. So we can take 8 and 0. So let us start. So this was 243. I'll take some 250 over here, or let me take some middle value first. Let me take 10, and let's start with this simple value. Over here in the derived equation, this entire equation, 2 into now x value. What is the x value to be taken? 10 to the power 2 by 5, and now minus 3 to the 3 into x is again 10. Sorry, I need to multiply to the power, it's 1 by 5 now, 1 divided by 5, and now we need to close the bracket. Just write it properly, and that's multiplied with over here 2 divided. See, now we had written x to the power minus 3 by 5. Over here they have taken this x to the power 3 by 5 down, so that is why they're getting this. It's one and the same. It's not wrong or error, it's same thing. 5 into, that is x is considered to be 10 for now, the test value, to the power 3 by 5, and then minus 3 divided by 5x, sorry, x is 10, sorry, x is 10 power, no, it's, sorry, 10 to the power 4 by 5. Okay, we need to close the bracket. Now we can see over here between this was 10, the values between this, over here you get negative, so I'll put a minus sign. Let's try less than 7 point. Let's take, see, we have taken 10. This was some 7.5 value over here. This was 243. So we took 10, that is representative of all the region over here in the middle. So let's take less than 3 by 2. That will be, say, I'll take 0 for easiness. Let's just take 0 over here. So from the 10, I'll just remove 1, because 0 is less than 7.5. Over here, instead of x, I'll take 0, and this is the thing. And now, okay, so my bad, you can't take 0, because over here divided by 0 happens, and so sorry for that, I didn't even think that through. Let me take 0.5. So everywhere let me take 0.5. That was very silly of me to do that. Anyways, now over here let me take 0.5 as the test. Remember, when you're taking a test value, you must maintain the same value everywhere. And now I'm getting a positive value. So this was positive, this was negative. You can try similarly over here. I can see this will be again positive. And so with this little information, you can understand. See, I can understand this is going up, then down, and then again up. So this 3 by 2 is maximum, whereas over here this is minimum. So this is how we can understand the graphing from critical numbers. This is how we can understand the graph, not thorough. And in the next video, I will tell you a direct method to find the graph, because if the graphs are given in the 4 options, you can easily use your calculator and solve and understand which is the correct graph. We will do it in the next video. So please try the other problems by yourself. And the next topic is the same one. We will continue in the next video now. The third topic and the previous topic, that is topic number 2, which we did in the last video, are the same. It is the same objective, same exercise number and the page number. So now over here, it depends on how the question can be asked. Either generally it's to find the critical numbers, and if at all they ask you the graph, say these are complicated graphs, there is a direct method in calculator to find this. So what you can do is, you can see this is the graph over here, sorry, this is the graph. You will have 4 options. Only this is possible only when you are MCQs. You will have 4 different graph. You need to select the correct graph for this complicated function. How would you understand? Now this is sine and cos graph. You can understand its curves, something like this. Now try and see the graph thoroughly and see where the graph extends. So all these are the values it's extending. Choose any x value. Say I will choose 1. So 1 is something over here. Let me choose 1. And instead of sine, instead of x, we will just put the x value. But most important thing, if your calculator is cleared like this, it will default be in the degree mode. You cannot solve sine and cos in degree. You should change it to radian. That is by shift, mode, and 4. Now it's in radian mode. Now put sine, x value is 1, close the bracket. Multiply it with cos, 1, close the bracket. And now when you press equal to, you'll get 0.45. If you look closely over here, it is around, yeah, 0.45-ish. So that is the thing. Similarly, you can take other values. Now this is pi by 2. It's about 1.57. Let me change this to 1.57. And over here, 1.757. Why I did? Because I know that is pi by 2 value. And that is, now you can see it's 0.000. There are 4 zeros, sorry, 0.3 zeros and 7. So that means it's almost close to 0 because I have not taken the exact value. If you had taken exactly pi by 2, say for example, I'll just do that because we are using a calculator. So it's very simple to do it. Say now, for example, pi by 2 and pi by 2. Now you'll get exactly 0 because this is the graph. So same way, try to do 3 to 4 points in different ways. Say for example, now change it to 2. Now just have few points, and then when you're doing this, you will eliminate all the wrong graphs and only one graph will be remaining with you. See now 2 is somewhere over here, that is 0.378. So you can do it accurately. So if you put a scale, you will get the accurate answers. And that is the thing. So this is how we can easily solve it. This can work for any graphing, provided the equation is known. See now the equation is known over here. Anyways, we just look into the method over here which is used. See, this is sine and cos. Now you need to derive it first to find the critical numbers. When you derive it over here, you're getting uh, you have to use the product rule. Okay, after using the product rule, you can see over here product rule, this you might remember, u dash v plus uv dash. Just remember, u is the first function. Now sine, derive sine, it'll be cos x. Then v is the second function. This is uv. Product rule is u derived, okay, v as it is, so cos x, plus what is u? That's sine x as it is. But derivative of f dash is minus sine x. Now this is the thing. Now minus and plus becomes minus, and sine becomes sine squared. This is cos squared. This is what we are getting. Now take this to the other side and simplify. Take the square root. We get this answer. Now over here, what you can do is, now we need to know where exactly sine x and cos x are equal. It is at pi by 4. Now one more method is, it's in radian, so I will just write cos x equals sine x and shift and solve. Now that is 0.785, 0.785. Now what is this equal to? You might have remembered 1.57 is pi by 2, 0.78 is pi by 4. So all I need to do is pi by 4 over here, 0.785. So this is the thing. Now if you have some knowledge of the graph, whenever your sine and cos, the period shrinks. Otherwise the period is pi, isn't it? Now the period shrinks into half if you graph this in graphing calculator, because they have asked you to use the graphing technology. But otherwise, just remember, when you're multiplying 2 sine and cos, the period shrinks down. Now over here, at every pi by 2, it's not 2 pi, see 2 pi is over here, they've given, it's not just going like this, it has shrunk. See, it's going like this. Now what I'm trying to say is, one answer, yes, you got pi by 4. Next will be at, sorry, this is for the critical number. This is at pi by 4 over here. And then you need to keep on adding pi. See, at every pi, at every pi by 2, the um, intercept at the x-axis. See, you can see the solution is there. So we need to keep on adding pi by 2. So add pi by 2 to this, you will get, we can do it in the calculator, pi by 4 plus pi by 2, that would be 3 pi by 4. So next again add pi by 2. I'll just multiply it by 2. You'll get 5 pi by 4. Or you can just keep on adding. If you're getting confused, just add plus pi by 2. And how much we have to do is until we exceed 2 pi. Don't exceed 2 pi. See, 7 pi by 4 is almost 2 pi. No, it's 1 less than 2 pi. Okay, 7 pi by 4 is 1.75. If you add one more pi by 2, it will be more than 2 pi. So the period over here is given, the interval, sorry, is given 0 to 2 pi. So only this much. You might have, you obviously know this, right? The cos graph and the sine graph keeps on going, right? The solution keeps on coming. So over here, it just goes on forever. So if they don't give an interval, that means it's till infinity. So that's why they have given the interval to solve just till that point. Now over here we can easily find this first point in the calculator, then just keep on adding pi by 2 and you will get the solution. So these are the critical numbers. Now how would you find maximum and minimum? Now that is, you can do the same method what was taught before and you can find it out. Otherwise, if you understand these graphs, you can see this starts from 0. See, now for example, how would I understand? Let me start this sine 0 into cos 0. Where will it start? Because sine 0 is 0, it should start at 0. So it starts at 0. So just start over here, the starting point, and then put another value, say pi by 4. So when I do pi by 4, I'll get one more value, that is 0.5. Instead of 0, I'll put pi by 4. So even without the graph, just to understand which is maximum and minimum, now I came to know this is positive value. So after 0, it's going upwards. The graph is going upwards. So this first value will be up. Then it goes down. So this will be maximum. This will be minimum. Minimum. Again, maximum, minimum, maximum, minimum. So that is the thing. So the local maximums are pi by 4, 5 pi by 4. Whereas minimum is the remaining values. So this is how you can, try and solve this as well. There are many methods. So the over here, uh, see over here, x0 is also a local minimum. Why? Because it starts over there and this is a closed interval. See, look over here, the interval are closed. Whenever the intervals are closed, we include those points as well. Now where is 0? Over here. So this is minimum point and this will be maximum because it's going up. Okay, so this is how we can solve it. Just be thorough. Just try to remember the steps. If you understand the step, that is first derivation, then equating to 0, finding the critical number, then draw a straight line, put the critical numbers, take the test values and all the sections of the critical numbers, and then put it in the f dash equation, f dash of x. Put it over here. If it is a positive value, then it's plus. Negative value means minus and plus. If it's positive, it increases. Negative means it decreases. So at this critical number, it changes its direction. Again, it's plus, it will change. So then we can see if it is like this, it's changing from up to down. It is maximum, and over here, this is minimum. So this is how we can solve this type of problem. And if it is only graphing, then as I told you, just take a calculator, take random values in the x value, put it in this equation and see the graph. Only one graph will match the given equation. So graphing is very simple. Take the values, put it over here and check for the correct option. So this is how we can easily solve this. Moving on to the next topic, the topic number 4. This is continuation of the previous topics. So I would request you to watch the videos in continuity. So please watch the video number 1, be thorough with it and then move to the next video. And one more important thing is when you're watching these videos, have your rough paper, rough book with you, try solving the problems and then check the answers because all the answers are available in the presentation. So check the method, check your understanding, and check the answer keys. Now, the fourth topic, you have to use second derivative test. What is second derivative test? Now imagine you have a function, derive it once, you will get first derivative. Then equate that to 0, you will get the critical numbers. And if you derive this derived function again, it is second derivative. So now there is one thing, the second derivative test, what it says is, you need to derive one function. Okay, we get it, equate to 0, find the critical numbers. Say you got minus 3 and 2. Okay, two critical numbers. Then what you need to do is substitute these critical numbers instead of x in the place of second derivatives. Instead of x, put these critical numbers. Wherever the equation will be there, don't put x, put critical numbers and solve. And now what it says is, if you get greater than 0, if you get a positive value, remember, if you get a positive value, it's a local minimum. Let's see why. Because in second derivative test, if you get a positive value or number greater than 0, it open upwards. See, a parabola, when it's positive, it will be opening upward, isn't it? But the value over here, the maximum, absolute minima or maxima, it's minimum point, local minima. And similarly, if you get less than 0, that is a negative value, it will open downwards, and this over here is maximum point. Okay, so this is the things. And then um, so over here you will understand what is the maxima and what is the minima. So now imagine minus 3 you substituted and got greater than 0, so that means that is the local minimum, maximum, sorry, greater than 0, it's minimum. So that is the thing. Same way, substitute another critical number, whatever the critical number is, imagine 2, put it in the second derivative, you'll get an answer that should be maximum, or it should be positive or negative. Based on that we will solve. We will do a problem quickly, you'll understand much better. This is the function. Let's derive it. This is the basic thing. So it'll be 4x to the power 3 plus 12x to the power 2. Now don't do anything with 1. It'll be 0 because there is no x. Now let's use the calculator and find the solutions. Mod 5 and 4, that is for cubic. The answer is 4. X square is 12 and there is no x and no number, so it's 0 and 0. The answer is minus 3 and 0. So you got the critical numbers minus 3 and 0. Now you need to derive it again. Let's do the derivation. F double dash of x, it'll be 3 times 4 is 12, x square plus 24x. Now all you need to do is substitute these critical numbers over here. Okay, I will put this minus 3 over here, so 12 into minus 3 the whole square plus 24 into minus 3, that is equal to positive value 36. So now whenever you have a positive value, you will have a local minimum. You can see f double derivative minus 3, the value is greater than 0, so it is a local minimum. What about the first one, another 0? Put 0 and 0, it will be 0. So now over here, this is inconclusive. That means you don't have the exact answer. So over here, they have just left like this, because over here what happens is, if you had graphed, it is neither, it might be neither, it is not local minimum maximum. That is the thing. So if you want thorough understanding, if you want to know thoroughly about the graph, you can do the method which we employed. Write the critical number 0, sorry, it will be minus 3 first and then 0. Take the test values, substitute in this, and you will get plus, minus, minus, or plus, so on. So that is how we can do it. Same way you can solve the others. It's very simple. Just make sure you find the critical number, put it in the second derivative. Over here, only one critical number, put it over here, and it was greater than 0, so it's local minimum. Similarly, over here, the equation might be complicated. Only thing is you need to derive it. Over here, you should use the product rule. It is u dash v plus uv dash over here as it is, and then simplify how much you can, find the critical numbers, and then you need to put Double derive again over here, double derivative, it'll be product rule, and then substitute this critical number over there. So it was less than 0, that means it's a negative value, and you have local maximum. So this is how you can solve it. Please go through the other problems, solve it by yourself, and then check the answers. The fifth topic is again continuation of second derivative. We need to know the second derivative information. We had just done basics in the last video, that is topic number 4, but here they're asking us to graph with thoroughly, in the sense we need to do the first derivative, find the increasing decreasing maximum minimum points, and then we have to do the second derivative, find the concavity, and then understand the graph. I will do one problem in brief, this one, and then I will tell you a shortcut method to easily find which is the graph given the function. Because the functions are given in the 4 options, you can easily choose the correct graph. I have done it already in the previous video, but I'll just repeat it in a while. So now to graph this, now it's very simple. I'll just show you over here how it's done. Now this is the function. Given function is over here, square root x square plus 1. You need to derive it. I'll just write the formula root x derivative is 1 by 2 root x. Remember this always. And then over here, it's a chain rule because there is another function x squared. This is also a function. So what happens is square plus 1 multiplied with the derivative of x squared, that is 2x. So you will get 2x divided by 2 root x squared plus 1. This is the thing. Now you can equate this to 0 and find the critical numbers. When you equate it to 0, this becomes 0. X is equal to 0. Okay. So then what next? So we have found the first derivative, very simple, straightforward. You can do the signs. We have done this before. Critical number is 0. Take value less than 0 and greater than 0. Let me quickly take some value. Over here minus 1, over here plus 1. Put it in this. So minus 1 divided by minus 1 the whole square plus 1. Minus 1 remains. What happens over here? Minus becomes plus. It will be 1 plus 1. It will be root 2. I do not need to solve this. I just need the positive or negative. It's negative answers. Whereas if I take plus 1, see, this will be plus. It will be positive. Very simple. Now, next would be understanding it's decreasing when it's minus and increasing when it's plus. So I know basic of the graph, it's something like this. We need to know more, okay? So what do we do is, we need to, see, this is where it's increasing and decreasing. We need to do the second derivative. Now, the second derivative of this function over here, see, over here, this is simplified and written over here, okay? Now, we need to know the quotient rule. U dash V minus UV dash divided by V square. It is similar to the product rule where U dash V plus UV dash, but over here it's minus and then this denominator is added, squaring. Now let's solve it. U dash. Now I'll just show you over here. See, you have to derive the first function, the U, that is upper U and V, okay? U divided by V. What is U? X. You need to derive this. Then multiply with the V as it is. Root x squared plus 1. Minus, over here, keep the U function as it is and derive the square root x squared plus 1. Divided by square of square root x squared plus 1. Now here, see, this cancels off. And what else? You need to start deriving it. Over here, when you derive, you will get, so over here it's very simple, it's 1, so this is gone, so only this is the answer. But over here x will remain, and this derivation we did it right at the beginning. Say this is the derivation of this. Over here it's the same function we get again. It will be 2x by 2 root x squared plus 1. This 2 and 2 cancels. See, now the numerator needs to be simplified. You can do in various methods. See, there is a numerator in the right side. There is no numerator. Let's take a common. So before taking common, multiply and divide this numerator. X squared plus 1 divided by square root x squared plus 1. Only for this first term. I have not done anything wrong. See, imagine 2 by 2. I multiply it to 3. Does it make any difference to 3? No, because it's 1, isn't it? So this answer remains same. If I multiply and divide same quantity, it's the same thing. So it's fine. Now, what happens over here when I multiply this? Power half and power half, it'll be x squared plus 1 divided by square root x squared plus 1. And minus, over here it is x squared divided by square root x squared plus 1. Now, I hope you understand this is the step over here. And now you can just simplify it. You can just write this square root x squared plus 1 together. This term minus x squared, and this cancels. And this term can go down. It will be x squared plus 1 multiplied by this term. Now over here, see, x power 1 multiplied by square root means half. What is the power? It will be x3 by 2 or 1.5. So over here we will have 1 divided by x squared plus 1 to the power 3 by 2. Because we are adding the powers. Nothing means it's 1 and square root means half. Add it, you will get this. What next? Now we will find the critical numbers. Make it equal to, we will find the inflection point, but make it equal to 0. Now take this to the other side. What happens? It will be 1 equal to 0. Is it correct? No, it's wrong. So it cannot be equal to 0. Okay, double derivative cannot be equal to 0. That means there is no inflection point. Now let's take any over here. What it means is, see, it's concaving upwards. How? Take any point other than 0. See, take any point greater than and put it over here. It should be greater than 0 and not equal to 0. So just take, it should, if you solve it over here, x squared plus 1 greater than 0. So x squared must be greater than minus 1. So we can just take a value, say 3 or something. Test over here. It will be positive. So you're getting positive answers over here. And then we don't mind what is the answer. We just want other than 0. Even if you take minus over here, it will be positive only because square is there. Okay, we are getting positive answer. That means it is concaving upwards. So now it's concaving upwards from minus infinity to infinity. And over here, there is no inflection point we saw over here. Now, with all this information, see the increasing, decreasing concavity, you can come to the conclusion of this graph. So looking at certain things, you can easily find out this graph. Okay, that is how we do it. Now the easier method, which I already told before, instead of doing all that, see there are, okay, end behavior is there. End behavior means take a big number in the x-axis in the positive side. See, it's up to infinity. Say take 100 and put it over here. If this is keeping on increasing, that means it's going towards infinity. If it is increasing negative number, you get some negative 999, then it is decreasing. So this is the end behavior. Now imagine the graph is like this. If we take a negative value and put it in the equation, it would be minus value. The right side would be plus value. This is the end behavior part. Now there is no horizontal asymptote. Intercepts can be found out. All this can be found out, and ultimately you can zero down to the correct option. But there is one more easy method. You can just take out your calculator. You will have 4 graphs, isn't it? Because we have to graph. This is MCQ, topic number 5. Just choose x values. So I will choose, say, 4. Put it in this equation. The square root of x is 4. Sorry, I had to put 4 squared plus 1. Now, what is the answer? Square root 17. That is 4.13. So let's see over here. 4 is about 4.13. Yes. If you take a proper scale and measure, you will get the correct answer. Let me take 0. Over here, 0, it will be 1, obviously. So that's the 1. And any value, say for example, minus 2, use the bracket, minus 2, the whole square. You will get square root 5, that is 2.3, somewhere over here. Yes, 2.23. So this is how you can easily graph as well. This can work, this whatever I just now told you can work anywhere. Now let's take over here, say I'll take value number 3 and put it over here. 3 plus sine 3. Since sine is there, make sure I put it in radian, shift mode and 4, and I will get now the answer. 3.14. Yes, that is almost correct. Same way you can check all the other graphs and you can easily get it graphing. Otherwise, just do the method which we just now did. Oh, this is very important. First derivative, second derivative, and then you can easily understand the graph. The sixth topic is similar to the fifth topic. Here also we need to sketch the graph using the first and the second derivative properties. There are many methods to do it. We will use the first and second derivative property, and then just like the previous video, we will directly solve graphing in calculator. Now over here, first is always the finding the derivative. Find the first derivative, that is f dash of x, and whatever the answer you get over here must be equated to 0 to solve for critical numbers. Now over here when you solve, you get the critical numbers as 0 and -3. If you are getting confused with this, all you can do is put it in the calculator and you can get it mod 5 and 4 for cubic. So type the values. What is the coefficient of x cube? 4 of x square is 12, then it's 0 and 0, and now you'll get -3 and 0. So this is the critical numbers. Now after the critical numbers are there, you can draw the diagram for the increasing and decreasing parts. So this is studying the first derivative. You've done the derivative. Take the critical numbers in ascending order. -3 is first, then 0, and take any test value less than -3. So I can take -4 or -5 or -10, anything, it's fine. You will get the same answer. You need to take this test value and put it in the f dash of x. Instead of x, put -4 and solve. And then from -3 to 0, say for example 1. Take this and put it over here. And lastly, from 0, sorry, I have made a mistake over here. It's -1 over here, put it over here. From -3 to 0, it's -1. And lastly, you can take 1. The reason why I'm taking simple values is it's easy for you to calculate. If I take 1, I know it'll be 4 plus 12, so it'll be again plus over here. Otherwise, if you take say 10 or 20, it's going to be it'll take time for you to calculate. Take simpler values, it's easier. Now after this, you will come to know over here it's decreasing and then over here it's increasing, both the points. So we know increasing function is from -3 to 0 and from 0 to infinity, whereas it's decreasing from -infinity to -3. And what next? We need to find the second derivative. Before there, this graph is something like this and it goes up. So we have a local minimum at -3. So this is the value. Now next one is second derivative. Find the second derivative and then you can find the concave up and down. But after finding the doing the double derivative, you need to equate this to 0. I'm sorry, I just realized this. This is double dash over here. Okay, this must be equated to 0. How do you find this? We have first derived it, right? F of x was derived, we got this. Now derive this again. 3 times 4 is 12x squared. 2 times 12 is 24x. And then you can put this in calculator. I'll show you over here. Now it's mod 5 and 3 because it's quadratic. Power 2 is maximum. It's 12, 24, 0. The answer is -2 and 0. Now over here, again you can solve the same thing. Similar, just like what we had done studying the first derivative, we can study the second derivative. Now over here, you must take the values from the second derivative. Okay, these are the inflection points. Now take any test value less than -3, -2, sorry, over here. It can be -3. Over here you can take as -1 and 1. Now don't put in f dash, you need to put these in the f double dash or the second derivative values over here. This value, so -3 will be over here, 12 times -3 whole square. That's 24 into -3. That's how we do it. Now once you solve it up, you will get over here plus, minus, plus. So what happens is wherever it's plus it opens upwards, wherever it's minus it opens downwards, and wherever plus again it opens upwards. So it's concave up, down, and up. See, if it was just so much information, we just know it's something like this. But now we have more information. Now we know it's concaving upwards and then downwards, and then again upwards, something like this. We know the graph is going down, up and up, but we know it is upwards till over here till -2, and then it is downwards till 0, and then again it is upwards. So we get a better understanding of the graph. This is very, very useful for that. And this is concaving upward, the regions. Now over here we have inflection points. Inflection points are the points when we equate the second derivative to 0, we get the inflection points. Now then graphing, we can find the end behavior. Just put the x value, huge x values, and solve it up. You can get it, or there are many different methods to do it. Now they have used long methods to solve the y-intercept and y-intercept of the graphs. Now over here, this is the final graph. Now I want to quickly make a point. We had concave up, down, up, and we had only decreasing, increasing, increasing. This is very, very crucial information because you have to finally draw the graph. So you will have four graphs. How easily by first and second derivative you can find out is from the shape. This tells us till -2 it is concaving upwards over here, and -3 was the minimum point. We got it in the first derivative. -3, you can check it back, and this -2 it was upwards. Then it is increasing. Yes, it's going up, but look over here. It is concaving downwards until 0, and then from 0 the inflection point where concave changes goes upwards. So the inflection points are very important. We had got -2 and 0. These are the points where concaving upwards or downward changes. See, we had at -2 and at 0. So you can see over here at -2 it's upwards, and then it's downward, upward. So this is the thing. Otherwise, we had seen in the previous video just directly to use calculator. All you need to do is over here in your calculator, type this out. For example, take any value, say -2.5. Instead of x, put the -2.5 value. -2.5, the whole power 4 plus 4 into, now again, -2.5 cube -1. Now the answer is -24.43. Let's see at -2.5. Yes, it's about 24.43. Similarly, take any point and check the answers. Now you will have the four graphs because this is topic number 6. You will have MCQs and you will have the graphs. So just you will be given with the equation and you will have four graphs. So trial and error with all the four graphs and you can find the answer. If not, you can just use this first derivative and second derivative. It is very, very straightforward. You can understand the the characteristics of graph and find the graph, or whichever method which you're comfortable with, you can follow that method.
Moving on to the seventh topic, it is to find antiderivatives of the function, that is integration. This is the next chapter, that is chapter number 5. Before we start problems, we need to look into the formulas. These are some basic formulas over here. Now, you can see these are the answers. I'm sure you might have gone through this because without this, you cannot continue in the coming chapters. But now I want to tell you some things, like basic things. Integration is opposite of differentiation. Now imagine you add x to the power 3. The differentiation of this would be the power is multiplied to the variable. It'll be 3x, and you subtract the power by 1. So 3 minus 1 would be 2. So this would be the differentiation. Now derivative is reducing the power by 1, but now you're dealing with integration. So this will be your question and you have to go up. That means you need to do what we did oppositely or inverse of that. So 3 is a constant, it remains. Now whenever you have x power 2, you need to add the power by 1 and divide by whatever is the power, the final power, that is 2 plus 1. So this basically is 3x to the power 3 by 3. Now this can cancel off and you're getting x power 3 as the answer. But always remember, when you integrate, you have to write plus c. I'll tell you why. Now I hope this is clear. The power is added by 1 and divide that, the final sum by divided, and then simplify it. Now when we are deriving derivative, now imagine you had a constant 2, x to the power 3 plus 2. This 2 becomes 0 because x to the power 0 over here, when you derive, it's 0. So we don't write this. This is excluded, isn't it? So now when we integrate, we only can get back to the function. We can't get back to the constant. We will only get the function, not the constant. So we write this c. It might be any constant over there. This is the reason. Now, we can see the other formulas. They are very, very simple. If you understand the derivatives, integration is very simple. But you need to be very thorough with derivatives, and then you can understand integration easily. Now, if you remember, derivative of cos was sine was cos, and similar. But I'll come to this the signs in a minute. Now, say for example over here, derivative of tan inverse was 1 by x, 1 by 1 plus x square. Now you will get the answer, that is 1 by 1 plus x square. Integrate this and you will get the tan inverse x. Same way, integration derivative of secant x was secant x into tan x dx, but over here integration of secant x tan x would be secant x plus c. Plus c is very important. E to the power x did not have any derivatives, so even integration is the same, but you need to add plus c. But when it is minus over here, because of power rule, this will become minus. Say, just remember, not because of power rule, the rule over here, minus sign, because when you have over here minus, if it's plus, it'll just be plus, minus, sign changes to minus, plus c. And similarly, the other formulas, these were the questions for derivatives, and this was the derivative formula. Now we have the answers, that is, integrate the formula, get back the derivative. What about these minus signs? If you look closely, these minus signs are only at C. C, C, C over here. That is for cos. If when you integrate and get the answer of negative over here, then add minus sign. Same thing over here, add minus sign. After integrating over here, you got minus cot. So it's minus. When if it's C. Whereas if it is other than C, that is tan, sine and secant, you don't have to. Okay. So the problems are pretty straightforward. Over here, you can do it directly. 3 x to the power 4. Add the power by 1. It will be 5 divided by 5 minus 3x to the power 2 by 2 plus c. This will be the answer. So that is the thing. And they have written the numbers fraction separately and the variables separately. It's anyway, this is the same answer. Now we will do a little bit complicated problem. See over here, you have powers. Now, square root and powers in the denominator. It is very important to know what happens when you change the powers from numerator to denominator. Say over here, 3 root x means x to the power half minus 1 by x square, x to the power 4. Just get the 4 up, but remember it will be negative 4. So this is the question itself. I have rearranged the question. Okay, the root is always over here, it's 2, so it is 1 by 2. Cube root would be 1 by 3 and so on. Now, you should use the power rule. Just now what we did over here. So it's 3 is a constant, leave it. Half plus 1 would be 1.5 or 3 by 2 divided by 3 by 2 minus x to the power minus 4 plus 1 is minus 3 divided by minus 3 plus c. Now simplify. See, it is 3 divided by 3 by 2. The answer would be 2, or 3 divided by 1.5. How many times? It is 2 times. So answer is 2. Otherwise, if you're solving it directly, this cancels, and the numerators, sorry, denominator go up, right, to the numerator. So it will be 2x3 by 2 minus becomes plus x minus 3, that is 3 by 3 plus c. So this will be your final answer. So you can see it is 2x to the power 3 by 2 plus x to the power minus 3 by 3 plus c. This is again similar. All you need to do, this is again minus only. It will be plus 1, and over here square root will be half. But it will go up, it will be minus half. So add half, it will be plus half. So this would be x minus half when you take up, plus 1, it would be positive half. Similarly, please do the others. Now we will do this one over here. Integral of, say, x to the power 1 by 3. Split this denominator to both the values over here. It will be 2 by 3 minus 3 divided by x 2 by 3. Okay, I have just splitted it up. Now take this up over here. When you take it up, what is going to happen? 1 by 3, this is over here, minus 2 by 3. Why? Because the power over here in the denominator, when it goes up, the variables are same, x and x. So this just subtract the power. Minus 3, take this up, minus 2 by 3. Now you need to integrate these. Integration of, see, 1 by 3 minus 2 by 3 would be negative 1 by 3. If you cannot do it in mind, you can do it in calculator, but the mind way it's easy. The denominator is same, 3 and 3. So write the denominator, do 1 minus 2, that is minus 1. Now x minus 2 by 3. And now if you recall, we had just done this a while ago. You need to see, add 1 both the sides and divide by the answer. So the answer would be over here 2 by 3, because when you add 1 it will be 2 by 3, and the divided by 2 by 3, which 3 goes up, we can write it as multiplied by 3 by 2, because 2 by 3 is divided, but when you write it in terms of, when you take the denominator's denominator up, it will come to the numerator. Same thing over here, minus, and minus 2 by 3 plus 1 is 1 by 3, therefore you get this over here, sorry, and divided 3 divided by 1 by 3 in calculator, if you do, you will get 9. That is the answer. Plus c, sorry, I've forgotten to write it over here. It's, sorry, I've not derived. Okay, so when you derive, when you remove this integral symbol, you should add plus c, because that will be the constant. Please do try the others. The sine and cos is simple as well. Sine derivative, sorry, it's integral, antiderivative, opposite of derivative. Okay, integral is minus cos. You can see over here, 2 cos sine x derived integral will be cos, that is minus cos, because answer is in C, and integral of cos is sine. Same way you can solve the others. Now these are sine inverse formula. Over here secant square is tan. Okay, what about this one? This is interesting. Now let us split this. See, you must be thorough with all the formulas. Only then it's easy to solve. Now, 4 is a constant. Leave it out. Integral of cos x by sine x, because it's square, multiplied by 1 by sine x. Now, cos by sine x is cot x, and 1 by sine is cosecant x. See, we know the integral for cot x or cosecant x, or cosecant x and cot x, is cosecant x. So it will be minus cosecant x. Okay, because this formula, if you go back to the formulas, you can see over here, cosecant, over here we have, and cot, when multiplied, it's minus cosecant. Therefore, we get minus cosecant. This 4 is a constant, right? Write the 4 plus c. And now, okay, there is one more formula which you must remember. Imagine I have 1 by x. What is the answer? If you recall, natural logarithm derivative was 1 by x. So integral of 1 by x is ln or natural log or ln x. This is pronounced in different ways. Ln, ln, or natural logarithm is the exact term. So now, why? Because imagine you have x minus 1. Let's use the power rule over here. What is going to happen? Minus 1 plus 1 is 0 divided by 0. Now, what is the answer by if anything is divided by 0? It is undefined. You're not going to get answer because it goes up to infinity. It is not proper, because you can divide anything by 0 infinite times, basically. So that means that you can't use power rule when it is x power 1 or 1 by x. So we use ln x with the magnitude at variable. Okay? Why? Because this x must be positive only. That's the domain. So this is how we solve it. Over here it will be 2 ln x minus cos x plus c and so on. These are very simple and straightforward. Please solve it by yourself and check the answers. Do the methods, check the answers. All the answers are available in this presentation. The eighth topic is just similar to the seventh topic. Now, if you're coming all of a sudden to this video, I would request you to pause this, go back to the previous video, that is video number 7, because we had solved plenty of problem in the last video. Now, I will just take two random problems in this and solve it again. Now, all the formulas, methods, everything was shown in the previous video, so please go back, be thorough, solve problems by yourself, check the answers, and then move ahead. Again, I will just remind you, it is better to watch these videos in continuity. Say now you watch the first video, then go to the second. Don't jump. It's better you watch in continuity, at least for the chapters. Now, if you're watching integration chapter videos, watch them in continuity as well. Now over here, let me solve one of this. So this has variables, all numerator, all the points, x plus 2x 3 by 4, x to the power 3 by 4 divided by x 5 by 4. Now, first you need to split the denominator. Over here it will be x divided by x 5 by 4 plus 2x 3 by 4 divided by x 5 by 4. Now, what you need to do is take this power up. The rule is if the variables are same, the exponents, right? When you take it up, it changes its sign. So over here in the numerator, the power is 1. Subtract the below power, that is minus 5 by 4. If it was minus over here, then it would have been plus, because minus of minus will be plus. Now add it with the second term, that is 2x 3 by 4. Let me write it properly. 2x 3 fourth minus 5 fourth. See now, if you remember fractions, 5 by 4 is 1.25 and this is 1. So answer is 0.25 or 1 by 4. If you do not remember, you can use your calculator. It's fine. And then you can write the answer. This is negative 1/4 plus 2x. Over here it will be negative half, 1 by 2. Because it's 0.75 minus 1.25. This is the answer. Now, it is not over. You need to derive this. So derivation is pretty straightforward now using the power rule. I'll go up over here. X negative 1/4 plus 1 will be positive 3/4 divided by 3/4 plus 2 is a constant. X positive half minus half plus 1 is positive half divided by half plus c. Now you can rearrange and write this will be 4x 3/4 divided by 3. So just remember, whenever the denominator of the denominator, it goes up to the numerator. Okay, so this is the thing. I'll write a by b divided by c by d. So now this, okay, let me change the color. A by b divided by c by d. This is a different term altogether. What happens over here is the denominator will be written with a. So I'll write it down over here. Whatever is in the numerator, see the top term will remain as it is. That will never change. So I'll write it in the same color. A by b. What do you do with the other terms? That will be, you should multiply. So this denominator, fraction can be written as a multiplication of d by c. So what you need to do is when you take it as from division to multiplication, you inverse it. So the denominator becomes the numerator. This bottommost goes up. Whichever is just below just jumps up. So C jumps up by 1, D jumps up by 2. So it will be AD divided by BC. I hope this is clear. Now then we will, so that's how we did the same thing over here. You can see it is 4 by 3. So plus, now it is 2 divided by half, it will be 4. Or take this, denominator jumps up. Over here, numerator is not this. So it's just 2 divided by half. So this 2 goes up, it will be 4x half plus c. And this is the thing. So this is how you can solve, and that would be the answer. All the methods steps are there. Now, okay, they have rearranged this and written. So I'll just write it like how it is written in the question, in the option. 4 by 3 is the constant. Now, you know, x power is 3. Whatever is down will be written in this terms of square root, and you put it over here. So now if it's only square root, it's automatically assumed as 2. So therefore we write 1 by 2, x power 1 by 2 over here. Okay. This 2 will be written 1 divided by. Now same way, if that number changes to 4, then you write 1 by 4. But since it's power 3, x3 divided by 4 plus 4 square root, only square root, x is enough because 2 is assumed, plus c. This would be the final answer over here. As you can see, that is how it is done over there. So please try to do it by yourself and check the answers. They are very easy. Once you start solving many problems, it is easy. But before solving, you need to be thorough with the formulas. So please try to write the formulas down a few times and then go through them. You will, imprint them in your mind.
Now we are in the ninth topic. Ninth topic again is similar to the seventh and the eighth topic. We are still in antiderivatives or integration. But now over here, we will learn a new formula. Let us just quickly see these both. They look similar, isn't it? 4x is just a number over here. X squared plus 4 over here, we have 4x squared plus 4. But how would you solve these? In the right side, you can recognize this can be, it's all numbers are constant, so you can ignore them. So this is ignored. These are same numbers, I can remove it out. I will have x squared plus 1. So what happens is, if I simplify this, 3 by 4 will be out. And then I will have 1 by x squared plus 1. Now, I hope you recall 1 by x squared plus 1 or 1 by 1 plus x squared is tan inverse. If you're integrating it, 3 by 4 is number constant, leave it as it is. This will become tan inverse of x. Now don't forget to write plus c. Very simple, we have seen this before. Now this is okay to solve, but what about this one? We don't have 1 up above, we have x over here. Now even over here, if you look into all the formulas, we do not have a formula which you can solve for cos and sine. Or over here, say for example over here, we do not have an exact formula for this. What do we do in such cases? Especially when we have numerator and denominator and we just can't divide it. So what do we do is, we will look into this formula. What it says whenever you have an integration to do of two functions, but the denominator's derivative is up above. Let me write an example. If I have 3x squared minus 2x, okay? And up above we have 6x minus 2. Now look carefully. Always when denominator problems are there, see the denominator, like numerator and denominator, look into the denominator. Derive this in your mind. It's very easy. 2 comes down, it will be 6x, reduces power by 1. Derivative is what we had done in the last term, the first chapter, chapter number 4 in this term exam. And over here, look at the right side, 2x. Derivative of x to the power 1 will be 0. So over here, only 2 will remain. So this is the derivative. Now these both are in relationship, isn't it? The derivative of the denominator is the numerator. Then don't go to solve anything else. The answer will be ln. Open the magnitude symbol. 3x square minus 2x plus c is always there for integrals. Now, if you're thinking why this magnitude symbol, you can try this. You cannot have, say now, let me just do it over here. You cannot have negative numbers, isn't it? Now let me try minus 2. What is the answer? It's a math error. But let me have positive 2. You'll get an answer. So you avoid any xy, this answer to be negative. So that's why the magnitude symbol. The magnitude symbol means all the answers will be positive. You can try this absolute value shift and ABS. Now put any negative answer, it'll be positive. If you put positive, it will just remain positive, but negative will become positive. It's magnitude. Now this is the way to solve. We will do one of this problem over here. Let's see this first one. Over here, look into the derivative, denominator. I'm sorry. Derive the denominator. It'll be 2x plus 0. So it's just 2x. Now look up above. Is it 2x? No, it's not 2x. It's 4x. But still, we can make this into 2x. How? Because 4 is equal to 2 times 2. All you need to do is split this 4, make it 2 into 2x divided by, only for the, wait, I'll write it clearly. All I'm doing is splitting this integral to separate, multiply by 2x. If I multiply this inside, it's same 4. So I'm just manipulating the numbers, but I've not done anything wrong. Now what do I do? Divided by x squared plus 4. Now this is dx. Always the dx will be there for integral. Now what happens is 2 is a constant, leave it. What happens to this part? Denominator derivative will be 2x, so we can just write ln magnitude x squared plus 4, close the magnitude symbol, plus c. So this is the answer. So this is how we can solve this. Let's just check the answer. It's 2 ln x squared plus 4 plus c. Now we had done this a while ago. 3 and 4 were removed common out. When you remove 4 over here, you should take from both, and so it will be x squared plus 1. See, don't get confused. You're removing this out, so it will be 1 and 4 is outside. If you multiply inside the bracket, it will become like this. So then, now what happens is, same way you can solve this. Derivative of sine is positive cos. So ln denominator is sine x, so that's it. Over here, this is just simple. You need to solve it using power rule. Now, over here, square root, take it as power half and solve it. This is 2 cos x, right? This will become 2 sin x. Very straightforward. Why cos derivative, integral, sorry. I'm sometimes interchanging the words. We are doing integral, but let me make it clear. When you use this rule over here, natural log, you need to find the derivative of the denominator and match upside, okay? Now, in this case, can you see there is any denominator like this? No, then only stick to the integral. Now, over here, integration of cos is positive sin x, so 2 sin x. Now, this square root is power half. Sorry, e to the power 2x into half. Now, this half and half cancel, so what is remaining? E to the power x will remain. The integral of e to the power x is e to the power x itself, minus e to the power x plus c. Over here, integral of e to the power x plus c is e to the power x, so we just write ln. This is like these three are using the formula which we just now saw. Now, don't be confused over here. See, over here what we do, one second. Split this, because if you integrate this, you will just get e to the power x, but there is plus 3. That means it's not the same. So you need to write e to the power x divided by e to the power x divided. You're splitting the numerator to both. Split it. And then now this is equal to 1 plus, take the e power x up, it'll be minus x. Now remember, when you're deriving over here, what is the thing? This, when you're integrating, sorry, this is simple. If it is 1, it will be x, okay, x plus 3 e to the power x. 3 is constant. Remember, this sign changes to minus, okay? X, see, derivative of 1 is x, minus 3 e to the power minus x, because the derivative of, I'll write it over here, the derivative of e to the power minus, again I'm telling derivative, I'm so sorry, integral, okay, the integral, because I'm using, both are being used over here, the derivative is used over here, the integral. I'm so sorry, please understand, only for these three problems we had used the derivative and compared it, derivative of the denominator to the numerator. But in the other three, even other three, we are just doing integral, we are not using that log formula. So let's see over here, one integral or antiderivative is x, minus over here integral of e to the power minus x is e to the power minus e to the power minus x. Therefore, this happens plus c. That is it. And you can see some more problems. They are very straightforward. We have done similar problems before. Multiply this inside. We are divided. Now it's just multiplying. So multiply over here. Remember, the powers will be added up. So x 1 by 4, when you multiply plus 5 by 4, this is quarter plus 1/4, that will be 1.5. So 3 by 2. And over here there is nothing, there's only minus 4x 1 by 4. And now I'm sure you know how to integrate it. Directly integration. We have done the similar way. And now this 29, see the last problem is 29. They have asked you to find derivation over here. In this case, so your derivation is from the previous chapter. Though these are all antiderivative, let's just solve this just in case. So derivative of ln x, ln x is equal to 1 by x. Since it's mentioned in the exercise, this might come. So let's solve all the problems over here. So there are three types of problem. One is normal integrals. One more is using the ln, knowing whether the numerator is derivative of the denominator, and then this one just to find the derivative. Over here, remember ln x is equal to 1 by x. So now over here, you will have to use the chain rule because there's a function over here and over here. So what happens is you will use the chain rule and get 1 by secant x plus tan x, and then derive this as again and write it up. The derivative over here will be secant x is secant x tan x is secant square x. Now over here you're removing common terms out. Secant is removed common out. And then you have tan x plus sec x. Over here also sec x plus tan x, which cancels, and you're remaining with the answer. So this is how you can solve these problems. Do solve many problems, and before solving you must be thorough with the formulas. So in the previous video the formulas are there, and this presentation has the formulas and all the methods. So please by heart the formulas, write and study the formulas, then solve this problem by yourself and check the answers. The 10th topic is to find definite integrals. Now this word definite integral means the integration for particular interval. It's definite, it's mentioned. There is a limit over here from 0 to 1 or 1 to 2. There are many methods to solve this. One is Riemann-Sum's method. By using the summation formula, it's a big method, so you can do this. Or you can also do, there is just integrate this normally over here and apply the limits. Integration of 2x is 2x squared by 2. And then apply the limit, that is upper limit minus the lower limit. So over here this cancels. You have x squared, right? When you apply the limit, what happens is, first upper limit, instead of x put the upper limit, that is 1 square, minus, instead of the x put the lower limit, that is 0 square. The answer will be 1. Same thing over here, just the limit changes. For x squared, because it's same term, 2x will be x squared. Upper limit is 2 and 1. So 2 square minus 1 square. The answer is 4 minus 1, that is 3. So just based on this limit, the answers changes. See, over here it is 3, over here it was 1. And the easiest of all method is obviously the calculator method. So I will show you this. Over here you can see the integral symbol, right? Integration symbol. Just press that. In the previous term, if you had watched the videos, I had used this shift and d by dx. This is for definite derivatives. Now we are using definite integrals, just this symbol. Now over here, all you need to do is type 2 alpha x, and this x is by alpha and x symbol over here, and then the limit is from 0 to 1. Let me type. The answer is 1. Or if it is 1 to 2, it will exactly give you the answer. So this is the easiest among all the methods, and it's in the first 10 topics. That means it carries 3 marks. So it's very simple. Just do the calculator method. You can easily do it. You can do any of these. Try all by yourself. You must get the answer. Just make sure when you're typing in the equation, be careful. Type it properly. X squared plus 1, and then put the limits properly as well over here and get the answer. The answer is 12. So over here, it's the same thing. I'll just do the last one over here. X squared minus 3, that is minus and 3. And over here, it is 1. So it is 8 by 3. Now, usually your answers will be in fractions itself, so leave it as 8 by 3. That is your answer. Even for negative limits, it's the same thing. Just apply it appropriately and you will get it. Over here, change the limit to minus. It'll be the same answer. Check your answer. Now, one more thing. Sometimes if you're getting an error or anything, just clear your calculator. It is by shift 9. Can you see above 9 is clear? CLR is clear. And then press 3 equals and AC, and then try and do it. So it'll be in default mode, and then you can start doing it. Do it by yourself and check the answers. The 11th topic is just same like the first topic. It is exactly the same, in fact, the same questions. So we have been asked to find the critical functions, the critical points for a given function. Now, over here, critical points are very essential to understand the basics of the graph, where it changes. Even to understand the graph, it is very important. It is very easy to find out. It is by f dash of x equals 0. That's it. So now we have done this before already. So I would request you to watch the previous videos and then come to this. Because if you watch in continuity, then it will be much easier as you progress. But anyways, I'll solve one of the problem over here. Now we have x to the power 4 minus 2x squared plus 1. All you need to do is derive it. When you derive, you'll get 4x squared x cubed minus 4. Now you can find the critical number by just equating this to 0. You can do this in calculator or directly algebraically. It's simple anyways. You can take 4x common out and you will remain with x squared minus 1, that is equal to 0. And now if you just equate both these terms, this is equal to 0 and this is equal to 0, you will get the answer. But yeah, you can directly equate it. So I can do it fx is equal to 0. That means x is 0. Okay, for the first one. Over here, you can directly do that. Minus 1 equals 0. So x squared is equal to 1. X is equal to plus or minus 1. Over here, they have done by splitting it. It's up to you. It's the same thing. You will get the same answers basically, 1 and minus 1. So are these are all the critical values. Now if they ask only critical values, it's fine, but they might ask you the maximum and minimum points as well. So now you need to take the critical values over here, substitute them 0, 1 and minus 1, substitute them in ascending order. Now what you need to do is basically take test values. A value less than minus 1, say minus 2. Less than 0 and greater than minus 1 would be minus 0.5. Over here also it will be 0.5 and over here 2. Now substitute all these values in the derived equation. So now here instead of x you need to put minus 2 the whole cube minus 4 into minus 2. You need to put it in the calculator, solve it. You do not need to exactly find the answer, but anyways we can just do it over here. When you cube, the sign remains negative, okay, and then for this will become 2 to the power 3 is 8. 8 times 4 is 32 minus 32. This will be positive 8. The answer negative answer prevails. It'll be negative 24. So the answer, we don't need the answer, we just need the sign over here, and it's negative sign. Same way you need to do it for all these over here. Say you put 0.5 over here and then try what will happen. So try for all and then you'll get the answer. Do it by yourself and then check. Then we will get an answer. So now over here, if you see the graph, it's negative. That means it is decreasing. And if you see until -1, the graph is decreasing. That's the thing. Now, if you put minus 0.5 and solve, over here the value will be plus because it's increasing until 0. And then again it will be minus and then it will be plus. And that is how we can find the graph. So now from this, without even the graph, just by this thing over here, you can get an idea since it's minus plus, it'll be like this, and like this. So now you can tell the -1 point is a minimum point because it's dipping down, whereas the 0 point is upwards, it's maximum. This is maximum, minimum, and again minimum over here. So these both are minimum, whereas 0 is maximum. If you see, even from the graph, it's the same thing. Only 0 is maximum, whereas the other two are minimum. Similarly, you can solve the other problems. We have already done such problem before. And this is absolute minima as well. Why? Because, see, the graph over here came down and then it was like this and then went up. So if you know the understanding of x to the power 4, it is like a quadratic parabola, but just that you will have some dips and turns over here in the middle. It's not just like a parabola, it's similar to a parabola. Now over here, you know, it's opening upwards. See, because it's plus, it'll open upwards. That means it can only have minimum. And those minimum points are absolute minimum because there is nothing below this. Okay, this will be the local maximum, but these also will be the absolute minimum. So this is how we can solve this problem. Moving on to the 12th topic, it is to find the absolute extrema of a given function. Before I begin this topic, I want to remind you that this topic is similar to topic 3, 4, and 2, 3, 4. Now, 12th topic is just similar to it. Uh, we have already solved these problems in the previous videos. It is basically we need to find the critical numbers, absolute maxima, minima, and then we need to understand about the graph. But now I had left about, the absolute value function problem. So I will quickly solve the absolute value function problem over here. Now this is the function given. We need to find the critical points, local maxima and minima. So whenever you have an absolute value function, you must remember the critical number. You know the critical values will be by derivative of f of x, isn't it? So we need to derive and find it. But in this case, also where the sign changes might be the critical points. What I mean is, if this is a graph where the sign changes at the x-intercept, so those also might be the critical points. So basically you need to find this points where the sign changes and then also find the critical values. So let us see how to solve this problem. Now this is given over here. Now here you just equate this function itself to 0 and find the x values. Why do we do that? That is because to find where it changes its sign. Now, what I mean by this is changing sign. Now, a function can change its sign when it passes the x-axis. So those are the values we are solving. So not by deriving, just for this function itself initially. Now we found out x plus or minus 1. And now let's find what are the signs for each of these intervals because it's an absolute value function problem. Now before -1, you can take any test value, say -2, -3, or over here you can take any value. I can take 0 for example, or 0.5, -0.5, and over here we can take again 2. Substitute in this function, that is x squared. So -2 the whole square minus 1, this would be 4 minus 1. We are getting a positive answer, +3. So that means this is positive sign. Similarly, try with 0, 0 square, 0 minus 1 will be minus, and again you can try with positive 2, it will be 4 minus 1, again same thing, positive. So what happens? We are getting positive over here, negative, positive. So this is the basic understanding. This is just to understand how it is. Why? Because this is an absolute value function. Now, if you recall absolute value function, anything minus inside, let it be minus x, the answer would be x. Or if it is x, it is also x. So this is the reason these are all the extra steps, because we need to split them at different intervals and see what are their functions exactly. Now over here, wherever it is positive, that means we are taking the positive value x square minus 1 itself. So all the values of x less than negative 1, we are just taking the positive value. Whereas over here also, greater than 1 is also directly x square minus 1. But I told you for minus x, see, even if it is minus x or absolute value of x, the answer is x itself, isn't it? So you need to understand the answers, the functions over here can be two, that is x square minus 1 or minus of x square minus 1. Multiply this minus sign inside, will be minus x square plus 1. Over here it is written as 1 minus x square. It's the same thing. So this is how we get this function. So when it is minus, just have multiply this by minus, and then for this particular interval it is minus. Okay, so now we know the critical numbers over here are minus 1 and plus 1. The sign changes wherever the sign changes, and since it's absolute value function, it is not differentiable. You can't There is no derivative of sharp edge or a corner, because you will never have a horizontal there's no derivative, because the slope over here will be 1 1, over here it will be undefined. Basically, you don't find the derivative of sharp edges or corner. That is what we had learned in the last term. Now over here, derive these functions, because there are two separate functions. So for this interval, the derivative of x square minus 1 will be 2x, over here it will be minus 2x, and over here it will be 2x. So now you need to equate it to 0 and find the critical number. These are the critical numbers. That is 1, minus 1, and over here, after we find the derivative, just equate it to 0. For all the cases over here, when you equate it to 0, it will be 0 itself. X is 0 in those particular intervals. So this is how we can solve for critical numbers. And you know how to graph over here only. So now for graphing, it is basic. See, now whatever you directly put the values, just shows this is not useful for graph, sorry. Take the graph critical numbers minus 1, 1 and 0. So now what you must do is, you must take test values and put over here in this derivative. So this is very important. Don't use this. Over here we just use to see where it is positive and negative. See where which particular function lies. Now if I'm taking a test value for minus 2, where do I put? X is less than minus 1, that means I have to put over here. At minus x is minus 2, it will be minus 4. So 2 into minus 2 will be minus 4, so negative value is over here. Now for this particular instance, see, that is from minus 1 to 1, we have to use this particular value. So now from minus 1 to 1, all these values, let me take 0 and put over here 0. So it will be minus again. Okay, I have done one mistake. I apologize for that. I cannot take 0. Why? Because I've took the equation wrong. I'm so sorry. Now, I cannot take 0. Why? Because it's a critical number. You never substitute critical number back to the derivative, because you should get 0. So that is my bad. I took this as the entire equation. Now, all you need to do is take a value within this range. So I'll take minus 0.5. So minus 2 into minus 0.5 will give me positive answer. So this will be plus. And let me take value of greater over here. So it'll be positive 0.5. See, from here, positive 0.5. Now let me substitute plus 0.5. You'll get minus. And lastly, let me take 2 over here. Substitute 2, sorry, not in this equation. See, not in this equation, it's in this. 2 multiplied by 2 would be positive answer. So now from this graph you can see it will decrease, increase, decrease and increase at the end. So this is the minimum point. -1 is minimum. This over here is maximum. See over here, minimum, maximum, minimum. We can understand from this graphing table. I hope that is clear. So I will just repeat few things. So you can find the local minima. But see, in this, if you do not have the graph, you have to do the test, trial and test, increasing and decreasing function method. I'll quickly recall this problem. Over here we have absolute value function, so it is not same like the regular functions. First, you need to consider this and make it equal to 0 and solve for x. We get plus and minus 1. And then now check where this function is positive and negative. So when we took a test value less than -1, we got positive values, then negative, and then positive. That means this positive function is considered over here and over here. See, it's positive. Whereas over here, minus, so you should multiply this by minus. Why? Because absolute value functions can either be positive or negative, and therefore it was minus over here. Then derive all these terms at these particular intervals. This is very important because when we do the test, you know, this 0, -1 and 1, we take the test values and put it appropriately. Now, if I take -2, you should put it over here, and I got a negative value. That means it was decreasing. And then when I'm taking a value over here, don't take 0. I took 0 and messed it up earlier. Just remember, critical numbers cannot be put in. If you put in, you should get 0 only. So that doesn't give you any reliable answer. It should be the positive or negative value. So take the value within this range, that is minus 0.5 or 0.25 or anything. Multiply over here, we got positive. Say it'll be minus into x is also minus, so it'll be positive. Increasing, that is. So these are the derivative. And same thing over here, also take a positive number, more than 0, less than 1. We put it back over here, it was negative, it decreased, and then last one we increased. So this is the thing. Therefore, we know minimum, maximum, and minimum points. I hope this is clear. I missed out initially when I was doing the topic 2, 3, and 4 videos. I missed this problem out. But now, please make sure you are thorough with this. This case is only when you have absolute value functions. Topic 13 is again another similar topic. It may not be exactly the same, but they are similar to the concepts, similar in concepts. Over here, they have asked you to find the critical numbers using first derivative test and also the location of maximum minimum points, which is the local maxima or minima. We can do it. We have done this plenty of times now. First, find the derivative f dash of x. That will be 4x cube plus this 3 comes, it'll be 12x squared. That's it. So now you can use your calculator to find the roots, or you can do algebraic substitutions. Over here 4 is common, so and take x square also common, sorry. So you're remaining with x plus for 3 times 12, so for x plus 3. So now the answer would be x is equal to 0 and x is equal to -3. These are the critical numbers. So we got the critical numbers. See, x is 0 and -3. So this is very simple. What about the next step? To find which is maximum and minimum. Draw a straight line. -3 will be somewhere over here. This is 0. And now take test values. I'll take -4 over here, says -1 over here, and 1. Simple values so that the calculation is simpler. The derivative is over here. I need to substitute it up over here. 4 into -4 the whole cube plus 12 into 4 -4 square. So now this will become minus itself. See now what happens over here? Since negative sign is there, for cube the negative sign will remain, whereas if it was a square it will diminish. So now what we do is over here We will just substitute this value. It will be around 416, 64, but negative. Negative is 4 times 64 plus, over here the negative sign goes, so everything is in positive into 16. Now looking at this, I'm not going to solve everything. Just looking at this, you can understand this will be a predominant value. See, this is much bigger compared to the other one because 60 is there. This will be 6 fours are 240 over 250, and this will be just nearly 200. So the first value over here, if with the test, is minus. So that is the thing. Now I've just done it directly, but you can use your calculator. It's very simple in calculator. Now next one, take minus 1. Substitute over here. 4 times minus 1 the whole cube plus 12 minus 1 the whole square. Always in the f dash or y dash, the derived function, you need to substitute the test values. And now over here it'll be minus 4 and over here it'll be plus 12. Okay, why? Because this will be positive and this remains. When it's odd power, the negative sign remains, whereas even power, it will diminish. It'll be minus into minus will be plus. So will be plus. That's why whenever it is positive, even power, it'll be positive, whereas the negative, another one negative will make it negative. So the answer over here is positive value, and take a positive value over here now. Positive one, sorry. This will be just positive because both the sides are positive. Now over here it will be plus 4 plus 12. Answer is positive. See, now you do not need to solve the entire value. You just need the positive value or negative value, because negative means it is decreasing, whereas positive means it's increasing, and over here it's again positive, it's increasing. So what do you understand over here is there is a minimum point at 3. 3 is a local minimum. You can see over here why? Because it's dipped, you know. But then it does not dip. So the graph will be something like this and it just goes on up. So x equals 0 doesn't have a maximum or minimum. So it is not an extremum. Why? Because it's not dipping, it's not changing. Only when it changes sign, you can write this maximum or minimum. So this is it. There is no graphing over here they have asked. But if at all the graphing is asked, we have done this already. So please watch the previous videos and you can easily know how to graph as well. Similarly, you can try the other problems. Now over here also, only thing is finding the derivative. Over here you need to use product rule. Find the derivative and then do the test. Once you find the critical number derivative, equate it to 0 and find the critical number and then do the test. Test values, substitute in the derived equation, and then you can easily find the answers. All the answers and steps are mentioned over here. So please do it by yourself and then check the answers. Moving on to the 14th topic, it is again similar to the previous videos. So first thing I would like to tell you is watch these videos in continuity. Now you must have remembered, if you have watched in continuity, you must be thorough with critical numbers, increasing and decreasing function, first derivative and second derivative. Now they have asked us to find the inflection point. First, let's see over here. When we derive the function once and equate it to 0, we'll find critical values. When we derive it 2 times and equate it to 0, then we will find inflection points. Now, this is what we need to solve for. Now, this is the function over here. You need to use the product rule. Remember, it is u dash v plus uv dash, and just apply. See, now this is the first function, second function. All you need to do is derive your first function is 1, so I won't write it. Just write e to the power minus 4x. And then plus u as it is, that is x is as it is, and over here e to the power minus 4x, because the derivative of ex is ex itself. But it's chain rule, derive minus 4x, it'll be minus 4. So the answer is e power minus 4x minus 4x e power minus 4x. Now over here they have written the negative term first and this positive term, because look at the product rule, it's plus. You can write this first or second, it's fine. But please don't go to do this with the quotient rule, because it was minus. You should not change that, okay? Product rule, any term, it's fine. You'll get the same answer. Now critical numbers, just equate it to 0. But before equating, you're removing this out, common term out. E to the power minus 4x is removed out. And this is equal to 0 and this is equal to 0. Now equate and you'll get the answer. Now why is this not equal to 0? Look, this is undefined over here. Even undefined points are fine. It's critical points itself. But you must understand there is no value for e to the power that'll make it 0, because even if this is 0, it's 1. It can never be equal to 0. Okay, you're raising something to the power, any power, it'll never be 0 in this case for exponential. Now over here, x is equal to quarter, that is a critical number. Now we have to I hope you remember this very well now, studying the sign of the first derivative, right? Where is the critical number? Over here. So take value less than that and greater than that and substitute in the derivative. That's over here. So all you need to do is substitute, say less than and greater than. You should use a calculator. Just you can do this simple substitution, and now if I put 0, for example, because less than 1 by 4 is 0, this term becomes 0 and this is 0, so it'll become 1, positive 1. So it's positive. And greater than 0, you need to substitute over here. It'll become minus, I believe, because this minus sign prevails. And whenever you add this will be greater because you're multiplying this, so the answer will be negative because of the minus sign. And then now we come to know this is increasing at the left side of the critical number and decreasing at the right side of the critical value. And this is just to understand about the increasing and decreasing. Now, this is not over. We need to find the inflection point. That is, we need to double derive it. Now, when double deriving, again, we need to use the product rule. It looks complicated, but it's not that complicated if you understand this well. Let's take this. First, first function. This is minus 4. Let me keep it out. Okay, now let's do this. First derivative will be 1. In fact, I do not need to derive this because this is the same as the given function, isn't it? So if I use the quotient rule, product rule, what am I going to get after I derive? The same answer. So you've already done it once. Just write it directly. I'll just write it as it is over here because I know that is itself going to be the answer. Now, don't forget this, derive this over here. It will become minus 4e to the power minus 4x. I've done the chain rule together. Derivative of e to the power minus 4x is same, then multiply minus 4. Now, if you're thinking how I did it so quickly, the product rule over here, minus 4 is constant out. X e to the power minus x, when you integrate it, derive it, you have to use product rule, and we have already done the product rule over here for the first derivative. It's the same function, so I did it directly. Now multiply this inside, it'll be minus minus will be plus 16 x e to the power minus 4x. Then this minus over here, minus 4 e to the power minus 4x, and this is also minus 4 e to the power minus 4x. Now we can simplify and make it short. Over here we can add these two because they're minus and minus. It'll be minus 8 4 e to the power minus 4x. And now you need to equate it to 0. Just like how we solved over here, you can solve it directly. So remove 8 common out and e to the power minus 4x common out. And then you are remaining with 2x minus 1. Now this is not equal to 0, whereas this is. So we will get x is half. And this is the inflection point. Okay, this half. This is the inflection point. If they ask only the inflection point, class, x is equal to half. Now we can again understand more of the graph by doing the concaving up or down. So take any test value, see over here less than half is 0, and substitute over here in the derived equation. See this I'll substitute because this is the same thing, simplified version. Now okay, it's anything is better. Now over here it will be 0. No, this is better, because the x's are separate. If I put x over here as 0, this is gone. And over here it will be 0, it will be 1, but this is minus 8. Minus 8 into 1, it will be minus sign. So we have minus. Same way, try 1. you know, greater than half. Okay, over here, do it in the calculator if it's getting confusing. Just instead of x, take the test value, put it over here. Same way with the right side, also take a test value, put it over here. You'll get positive. So, and negative at left side, positive right side. Concaving down and concaving up. So this is the thing. This is from the second derivative. Now you can get the graph as well from all the information. Sorry, from all the information we have, we can get a better understanding of the graph. See, now it is concaving. It was concaving down initially till the inflection point that is over here, and then no, sorry, the inflection point is over here. See, it's concaving down till over here, and then concaving up. And the critical number was over here. That is the maximum value. So say it was done over here, the maximum value was obtained. And see, from this much, we can get a very good understanding of the graph. But look into the question, what they ask you. If they're just asked inflection point, just stop it over there. Similarly, all problems, see x is equal to, this is a different problem. But anyway, similarly, all problems are solved over here. Make sure you solve it by yourself and check the answer. Over here, mainly they have just asked for inflection points. So over here, if you find these, second derive and equate it to 0 and find these values, that would be suffice.
The 15th topic is to use sigma notations to compute basic summations. Over here, this particular problem, type of problem, can be solved in various methods. I will go with the easiest and the simplest and the calculator method. Okay, so now before we start solving, we must know some basic things. This is the summation symbol. The intervals will be given from I to certain limit, say n. Over here it's mentioned phi. The function f of xi, the function f of x will be given. Xi means, I will tell you in a while, but before that, this delta x is like a spacing, you know. So now, here, the x values are given. See, they are repeating at a particular spacing. That spacing is delta x. Now, you must always remember, xi means, in terms of ith form, you should write this function. That means now x, let me just write it, x square plus 4x is the function. Now this x changes. This x changes to xi. Xi value is basically the spacing, the initial value, that is 0.2. Xi will be, sorry, xi will be, what is this initial value? 0.2 I. Okay, the initial value plus the previous value from 0.2. What is that previous value? It is 0. So whenever it starts with 0, we don't add anything. You know, in next problem, we'll see that adding part. But over here, it starts with 0, 0.2, 0.4, and so on. So xi is that, this is it. So instead of x in this function, just put xi plus 4xi. That will be equal to 0.2 I the whole square plus 4 into 0.2 I. This is what we do. Now, over here, you need to use your calculator. Summation symbol is over here, shift and this over here. Now, instead of x square, let me keep it over here. Instead of x square, open the bracket and write it properly. 0.2 I. The I is taken as x over here in your calculator. So write alpha and x. Close the bracket, square it. This is done. Plus 4, open the bracket again, 0.2 I is x, close the bracket. It will initially open and close a bracket by itself, so no need to close it again. Next, the initial value starts with 1. And how many values are there? 1, 2, 3, 4, 5, but they'll mention also. So this is it. Put in the calculator, you'll get the answer. Now, I have done for f of xi, but I have not finished the problem. So there is one thing, guys. Look at the function. What do they have to find? Compute sums of the form. Over here, delta x must be multiplied, and delta x is 0.2. I forgot to multiply that. So now let me do it. Please don't do the mistake which I just now did in the exam. I'll just close these brackets and I'll multiply with 0.2. And the answer would be 2.84. That is the answer. You can use the formula and do it, or directly it's the same thing.
But here this was a very easy one because it started from 0. Let us, even this will start from 0, but I'll just quickly do this in calculator. Now, over here, the first problem I just told you in detail, but we can directly do it. Shift summation. Now, what is the function? Over here, open the bracket. Always open the bracket because at the end you have to multiply delta x. So brackets are very important. So I'll write that, opening the bracket. Then 3. You don't write x. What is xi? That is 0.4. 0.4 I, the whole, no, it's just that much, sorry. I thought it was squared. Now, what next? Plus 5. That is it, because it starts from 0, 0.4, 0.8. That's it. Now close the bracket and multiply with delta xi, that is 0.4. So that is what I need to write. Open the bracket, 3 multiply again, open the bracket, 0.4 I is alpha x, close the bracket, plus phi, again close the bracket and multiply with 0.4. Now this is it. Sorry, see, now there's a syntax error because I have not put the intervals. That is 1 to 5. And now the answer over here is 17.2, and yes, that's it. So whenever it starts from 0, it's very, very simple. But now let's see another problem. Yes, this is a good example. Look at this problem. It doesn't start with 0. It starts with 2. So your xi value changes. It's same thing. What is the limit over here? What is the spacing or the step? That is 0.1 I. Okay. You need to add the value where it started from. That is, just see whatever is the first value, subtract this delta x. That is 2.1 minus 0.1 is equal to 2. This is the only difference. Now you are supposed to substitute 0.1 I plus 2 the whole square minus 2 instead of x. This is the thing. Why? Because it's not starting from 2. And don't forget to multiply delta x. Let us do this quickly. Summation over here, shift and the symbol over here. Open the bracket, 4 multiply by, again open the bracket, 0.1. I is alpha x in this, plus 2, close the bracket and square it, minus 2, and now I close the bracket and I multiply it with delta x, that is 0.1 again. So now the limits over here, it's from 1 till 10. So that's it. And the answer I get is 24.34. Yes, that's the correct answer. Same way, do the other problems. Okay, this is the last one, so I'll anyways do this quickly. Okay, let me do this because it starts at 2.05 and the limit is 1. So now xi is equal to, what is the step? 0.1 I plus the previous value. Now some of you might think it's 2. No, it's not 2. It is 1.95. Why? Because you have to subtract 0.1 from this value. It's 1.95 and multiply this with delta x, that is 0.1. This will be in summation. So now we just do the same thing. Shift, and over here what happens is, open the bracket, 0.I alpha x plus 1.95, close the bracket, multiply. Okay, sorry, I have not written this properly. Let me just make this clear. See, xi is this value. You need to substitute in this equation, okay? Now, this much is cube. See, because it's cube, x cube. Now, add this with 4. Close the bracket and now multiply. So, have I used the brackets? No, I have not used the brackets properly. I open a bracket. Again, I open and then that closes. And now the one more also closes. Now multiply it with delta x, that is 0.1. The limits are from 1 till 10, that is mentioned always in the question. And the answer is 20.24. Let's check. Yes, that's the correct answer. As you can see, this is the correct answer. So this is how you basically solve um, sigma notation, basic computations using sigma notations. The 16th topic is another easy topic. Now, I won't go in detail of this topic, but I'll just tell you how exactly you can solve this at left endpoint and right endpoint. Now, you must understand left endpoint means it starts from left side. Right endpoint means it must have the rightmost point, right endpoint. So now these are the endpoints, isn't it? Now, this is basically, let us understand what this table is first. This is the graph. They have given the basic details of graph. At x is 0, what is the y value? F of x is 2. And then you can see the values are increasing and then it's decreasing. Increasing, then decreasing, something like this till 0.6. They're asking you to find the area of this curve. Now, initially when you had curved objects, if they were not particular shapes like circle, rectangle, what they did was they divided this into small triangles, and they could find the area of each one, and they used to sum it out, and they used to find the area. Basically, now imagine this is the curve. You don't know which shape is this, so you just draw triangles, small triangles over here, and find the sum of all the triangles. You will get the approximate area of this curve before integration. Now, with integration, you can get the exact area, but without integration, you can do like that. So that concept we are using over here. Now, the method is very simple. Now, over here, uh, see how many, and see the sub intervals. Now we have 9 points. That means, see, the points are like this, right? I won't do it for 9 points. I'll just do it for four. So there are 4 points. How many intervals are there? Like over here, one, two, three sub intervals. So now in this case also, there are 9 points. See, one, two, three, four, five, six, seven, eight, nine. But how many intervals will be there? 8. Okay, so n value will be 8. Just remember. Now space it out. One, two, three, four, five. One, two, three, four will be there. And now imagine you're making these triangles from these points. Imagine you're making. So you have 5 points, but only four ends by sub intervals you'll be considering, isn't it? So therefore, this n is not exactly 9 if you count, it'll be 8. Okay, I hope you understood. The points are 9, but the sub interval will be one less than that. And see, you do not need to do all this formula to find delta x, that is the step. It's incremented by 0.1 over here. You're adding only 0.1. So directly you can take delta x as 0.1 from these values. Now you remember this. This is the formula. Now what it means is to find the area, you need to find the function of f of xi and 0.5. Now over here it differs. For left end point, all you do is start from this left end point. For right hand point, you must make sure that you include this point. What I mean is, you need to see this function means what? You need to, the function value is given. You need to add all these. See, add all this. That is 2 plus 2.4 until over here 8 values from the left side and multiply it with the step of 0.1. I'll just see over here what is done. Now you're starting with the left side over here. That is, this is a constant. 0.1 is a constant, delta x. That's outside. Summation is for what? Summation is for the function xi. That is starting from this 2, because we are doing for left endpoint now. Then next value. So we here 2.4. See, now whenever we consider these two, we are just considering the left values and so on. So now if you add them all up, let me just do it over here in the calculator. Just add them all up. Summation means adding the sum. But now since it's varying, you can't just use this, adding it manually. So open the bracket, 2 plus 2.4 plus 2.6 plus 2.7 plus 2.6 again plus 2.4 plus 2 plus 1.4. Now all you need to do is close the bracket and multiply it with the step of 0.1. Now that would be your answer. That is 1.81. That's it. Now for the right endpoint, if they ask you the both the answers, don't worry, don't clear it. Just change the first point. What is this? 2. Remove that. You don't need that. And add the last point, that is 0.6. This should be the answer. That is 1.67. See, if they ask you left endpoint, because they have told, sorry, we did left endpoint just now. We use this one. This is the answer for left because we started from left side. Now it's a right endpoint. If they ask for both, same thing, same method, only difference is you're taking the right from the rightmost value as well. It is 1.67. That's it. So you will be given the table, and with this just this table, you can understand what is the step, and you can easily solve it up. All are similar. Do try it by yourself. See, just remember which they're asking. If they're asking both, do it for both. Otherwise, just do it for one of it. So please do solve it by yourself and check the answers over here. Moving on to the 17th topic, it is learning more on definite integrals. Now, before we start solving these problems, let us say there's a function like this. Okay, this is a parabola. A quadratic function would be its function. Now, imagine this is the x-axis, and I need to find these two. These 2 points are known. Say -2 and 2. Now, the function of this, that would be, it's obviously x squared because it's parabola. And since it's below the x-axis, there'll be minus, I'm not sure about the values, but I'll just take a wide guess to be -5. Okay. Now, over here, let us find the limits. I mean, let's find the area. How do we find the area? I don't want the entire area because the domain extends forever till all real numbers. I just need it from -2 to 2. Okay, these are my limits. Now let us check it in the calculator for 1 minute. Let's put it integral. You can do the integration and put the solve it by using the limits. It's up to you, but I'm just going to do the calculator method, which is very easy and it's short and easy. So over here, alpha x squared minus phi, the limit is from -2 to 2, plus equal to, I'm getting a minus sign. Now, why I did this is just to make you realize, see, whatever you get in the calculator doesn't mean it's negative. It's just that it's below the x-axis. Area cannot be negative, isn't it? It's just that this region is below the x-axis. Okay, but now let me give you an instance where it would be in the y-axis. Sorry, I mean it would be like this. It's below. I mean it's below or above. Okay, by mistake to even y-axis. So now look at this region. Let's find the interval over here. But the equation wouldn't be the same since it's the vertex is above. It'll be over here. This will be minus. This will be plus, obviously, and this x squared would be minus, isn't it? Because the parabola is opening downwards and plus. If you don't understand this part, it's fine. But just see, this is the diagram and this is the approximate equation, and I'll just graph it over here. So it will be minus, and this will be plus. I mean, I'll just type it and we will directly find the answer. Now look over here, it is positive. So what do you understand is the orientation of the parabola is very important. If it is opening downwards, then it would be positive value. So you do not need to do any alteration. But if it was opening upwards and then this is the x-axis, then remember the answer would be negative. So add a negative sign to the equation to make it positive. Just make it positive. That is, if minus value is there, just multiply it by minus. So now with that knowledge, if you are trying to solve this, it'll be very easy. Now look over here. They have told you need to write all these statements in definite integral to find the area. The area above the x-axis and below this curve. See, this is the x-axis. They have told this is a curve. Now, since you need to understand this curve, how do you understand it? It's a quadratic, x power 2. And since it's minus, it'll be something like this. Okay? And this is plus 4, so it's above here. The tip will be at 4. Okay? The y value, it's around 4 over here. If this was the y-axis, okay, now that can't be the y-axis. Sorry, it'll be over here. See, now this is, but it's still not accurate, but this is an approximate. Okay, this would be 4 and it's opening downwards. Now they want to know the area above the axis. See, x-axis, this is the x-axis, above this and below this curve. So this is the area that you require. But now, how do you know these points where the limits are? How do you know? Now, looking at this equation, I will tell it -2 and 2. How? See, look, we have to find the x-intercept values. Whenever x-intercept, what is the y value over here? It will be 0. So equate this y as 0 and solve it. So it'll be 4 minus x square equals 0. So x goes to the other side, 4 equals x square. And take the square root on both the sides. It is plus or minus 2. That is x. So minus 2 plus 2. Now let us write the intervals. So it is integration from minus 2 to 2. Sorry, the limits are from minus 2 to 2. What is the function? 4 minus x squared. That is it. That would be your answer. So simple. Oh, now I have forgotten to write dx. Always dx will be there for integration. So now we can integrate this. So this is it. Now similarly, okay, now there's two cases. Whenever they ask you above x-axis, that means above x-axis and below the curve, or the curve must be, opening downwards. So this is the case. Even over here, it is very simple. You need to just equate this to 0. Now let us solve equating to 0. You can do it as quadratic, mod 5 and 3. Before x squared it's 1, and before x it's 4, and lastly there's no constant numbers, that's 0, minus 4 and 0. See, the answer will be, okay, now what did I do over here? Sorry, look over here, I've written 1, it's minus 1, so that's why I got the wrong answer. Just put the right values, exactly correct values, then you will definitely get it. See, now x1 is 4 and x2 is 0. Now always when we do it, we write in ascending order, 0 and 4. The graph is something like this. We need to find this area. So integrate this particular equation from 0 to 4. That's it. These problems are easy, but now what if the area is below? See, now it changes. See, they're asking like this. It's below over here. And we need to find this area, okay, for these equations. Starting concept is the same thing. Look, if you compare, it's the same thing. You need to equate this to 0, solve it, you'll get plus or minus 2, integral minus 2 to 2. But what is the difference over here is you're adding a negative sign. Why is this? The reason for this is because the answer over here, if you do without the negative sign, is negative, so it's below. Since it's below the y-axis, that's why you can just multiply it by the negative sign. Okay, so that's the thing over here as well. It'll be the similar thing. Now all you need to do is add the negative sign. See, the first 15 and 16 are the same questions. Only difference is, look, the negative sign. You can see this. Pause it over here, see these values, and then see these values. The only difference is with the negative sign over here and over. Okay, now sorry, I'll just make one thing clear. The equations are not the same. See, the equations are over here, it's positive, so it opens upwards. Okay. What I'm saying is the same thing. The method, the 0, everything is almost the same. Only the minus is the extra part. If you solve it, I mean, that's the only extra thing. Now let's see another type of problem like these. Okay, now over here, these are the last type of problems. The first and the second part is very easy, very straightforward if you understand the graph. But these are much more easier than the previous two, because over here they're asking the area between sine x. Now, sine, the domain of sine is up, it goes until infinity, right? It's all real numbers basically, domain. Only the range is restricted from -1 to 1. Now over here, so they will specify the limits, say 0 to pi. You need to know the basic understanding of sine. Sine starts with 0 over here like this, and it goes, okay? Now this will be 2 pi, this will be pi, where it changes, and now this is 0. Now from 0 to pi means this much. It's all above, isn't it? So now all you need to do is directly write 0 to pi sine x. That's it. Okay, see, they have mentioned the area between sine y and x-axis. Now let's see over here the area between sine x. It's the same thing, sorry, and the x-axis for these intervals. Now let's be a little careful. Now let me draw like this. Okay, that's not so. Okay, anyways, just for understanding, and let me go over here as well. Now, if you recall properly, see, this is somewhere minus pi by 2 is over here. Okay, why? Because this is minus pi, this is minus pi by 2, half of it, and this is pi by 2 positive, so somewhere over here will be pi by 4. So you need what? The area from here to here. So now if you're thinking, how will I know the sine graph? You need to know sine and cos. If it was cos, it will start from here. That's it. It starts like this. You can just use Desmos and check it out. What next thing would you do? Now, over here, you need to understand the left side is negative, isn't it? It's below the x-axis. So what we studied in the previous just now here, it was always minus. So remember that concept. You need to integrate it from minus pi by 2 until where it changes. Where is the inflection? I mean, where it changes its, from negative to positive over here at 0. This is the point. Until minus pi by 2 to 0, it is one interval sine x dx, and it's minus. Just remember to add the minus sign. Whereas over here 0 to pi by 4, it's same, just like what we did over here. 0 to pi by 4 is just sine x. That's it. So only for when it comes to trigonometric functions, just remember to use the graph. Now we move to the mean value theorem. I'm sure you must have heard this mean value theorem plenty times before. It is used in differential integral and everything. Now, to go in detail, it'll take a lot of time, but I'll just, tell you a basic about mean value theorem, and then we'll go on how to solving the problem. Now, imagine this is a function. It's a continuous function. We know this is the limits. That's for in between. This is the function, closed intervals. Sorry. There will be some value over here anywhere. C. You can take anything, but it's called to be C. If you put this value in the function, say instead of f of x, you put this particular value, you will get the average of the function. So this is an important value because it is a value where you can find the average of the function. And also say, for example, this particular mean value theorem can be used to find the tangents between the continuous functions. So you can find, say you're given the position, you can find the velocity and so on. But anyways, now for this type of problem, the 18th topic, there are two types, okay? That is over here. The first type of problem where you need to get the limits, see, the range between which over here this integral can exist. That is one thing by using this formula. And the second type is generally, every time it's used, that's the finding the c value that satisfies the integral mean value theorem. Basically you have to use this formula, substitute, and then equate it. We will see both of these problems in detail now. So you might get any one, but this might be more likely. Now what about this one? See, the graph won't be given. This is the function. Now if you just use your calculator and say, for example, put this integral 3 cos alpha x squared, close it, and over here it's pi by 2, sorry, pi by 3, and up over here is pi by 2, pi divided by 2. You get the answer. So the answer is 0 minus 0.236 and so on. But that won't be the only thing they'll ask you, obviously, because it's very easy to solve. Now, they might ask you the range between which your answer is there. So this will help you to find the range over here, the middle value, this is the mean value. But what are the end points, ending values? So where does this value of the integral lie between? So for this, there are a few steps. Now they have asked you to find increasing, decreasing function. I mean, it doesn't matter whether it's increasing or decreasing. The method was just the same method. Now I'll tell you what you need to do. These are the limits, right? For this function, apply these limits and solve. So it'll be 3 cos, instead of x, you need to put pi by 3. See, now remember, this is x square. Now, if you put like this in the calculator, it's wrong. The square must be inside, okay? I will show you in both the cases and solve the value. Similarly, put pi by 2 and solve. Let me just do it. Let me on over here. See, 3 cos pi by 3 the whole square. Now this, if you put outside, it's the cos pi x the whole square. It's like a bracket square. Okay, so this is wrong. Generally, if it's the whole square, they give you cos square x. That means it's the whole square with the bracket. Whenever the square is outside over here, remember the square will be inside up over here. So it is 1 point. See over here, we have already got it, 1.3698 and so on. Same way, just change the pi by 3 to pi by 2, and over here you're getting minus 2.34. Now what it says is, see, when it's pi by 3, which is less than pi by 2, somewhere over here, this is the positive value. Whereas for pi by 2, it's down, decreased, so it's decreasing function. Now we will just write which is the smaller value. This is the smaller value at pi by 2. So this is the smallest. There is no value within this interval that can reduce, go beyond this. Okay. See, this is the smallest. There is no value beyond this. But which is the biggest? It is pi by 3. That is the biggest. What is the intermediate value? Write this as it is. So we need to find the intermediate. So whatever this integral will be in between this. So all we need to know is this particular formula. So over here, this is the m value. What is the m? Over here, we just now solved, right? Minus 3.4. Function is given as it is, write the function. And what is the capital M? Over here it is. So substitute this. Now to solve this, you need to apply this formula. So this is directly by given equation, whatever is, given function, whatever the function is given, substitute the limits and these are the values. Now multiply it with the sum of the upper limit minus the lower limit. Sorry, difference. I told sum, sorry, it is this difference of upper limit and the lower limit. Now what it is? It is pi by 2 minus pi by 3. That's it. So now this multiplied by pi by 2 minus pi by 3. This over here changes. See, you're just putting the integral, nothing else. See, this changes to integral pi by 3 to pi by 2. Over here also you're multiplying pi by 2 minus pi by 3. Now solve these up in the calculator. See, all you need to do is over here, this is the answer. So I'll just take it as multiply over here. Pi by 2 is first, minus pi by 3, minus pi by 3, and you will get the answer over here. That is the answer. Now one important thing, guys, I forgot to tell you, that is we did this, right? 3 cos square and all. See, I'll just do that for once. By pi by 3, shift and pi divided by 3 square, like this. Now some of you may not be getting this answer, that because your calculator mode is not in radian. See, it will be degree default mode in degrees. See, this is wrong. You need to shift mode and press radians when we use trigonometric functions. Now you'll get the correct answers. Okay, so this is the thing. Now same way we multiplied over here, we got the answer. Now this can be also done in calculator easily, and over here. So the value of this integral must lie between these two. Now if you solve this in calculator, you'll get the answer over here. That is the thing. So this is the answer. This particular value must lie between these two range. So that is, about the mean value. But there's one more method, one more type of question where they will ask you the C value. This is very simple and easy as well, but you must know this formula. This is the mean value, finding the average value, the for integral, basically integration. See, this is integral with the limits. Now you have to find a C value that satisfies the mean value theorem. So you need to first find the value of that function. So there is one particular value somewhere over here that will be the mean value theorem value. So this is given, right? Substitute everything from the given function. So all the values which are given, say 0, 2, and all that, the limits substitute over here. 1 by 2 minus 0, integral 0 to 3, 0 to 2, and 3x squared dx. Now, over here, you can easily solve it up. Solve it. This is just 1 by 2, and when you solve it over here, you get 8. Or you can just put it in calculator directly. So it is 1 divided by 2 minus 0 is 2. Multiply with the integral. What is the integral? 3 alpha x squared from 0 to 2. That's it. Your answer is 4. See, half by 8 is 4. Now it's not over. So f of c is 4. Okay. Now take this equation. Instead of x, put c. Okay. Now we know this particular equation. What is that f of c? Over here, instead of f of x, put c. 3, sorry, c square must be equal to 4. Now try and find the c value. So now you're just taking, c 3 to the other side, divide and take the square root. It is plus or minus square root 4 by 3. But look over here. When you solve it, it'll be 2 root 3. This is beyond the limit. Is the limit less than 0 considered? No. So this is a wrong value. You don't consider the negative, only consider the positive value. Check the limits. Is it within this range? Yes. 1.15 is somewhere over here and the limit is below 2. The value of what we found is below 2. Yes, that is the correct answer. So over here, this only belongs to the domain of 0 to 2. So the C value is this. So this is how we can solve all these problems. Please make sure you solve it by yourself and then check the answers. All the solvings are there over here. Please do it by yourself. Just make sure you understand which they ask, whether they ask you to find the C value or the range, looking into the option and then choose the appropriate method. The 19th topic is again on definite integrals. Over here, they have given certain conditions, and you need to solve for the following questions. Now, the condition over here is integral from limit 1 to 3, f of x dx is 3. And integral, same g of x from the same limit is minus 2. So how do you solve it now? Look over here. You have the function f of x plus g of x. You need to multiply this limit inside. So when you multiply over here, it's like distributive property. It goes both the sides. Now what happens over here is when you multiply inside, it'll be integral 1 to 3 f of x dx plus integral 1 to 3 g of x dx. Now substitute what is the integral 1 to 3 limit 1 to 3 f of x dx. It's 3. And then over here it's minus 2. Solve it up, you'll get the answer. Similarly, over here you need to do the same thing. 2 is a constant, integral 1 to 3 f of x. Now next one would be minus, same thing, integral 1 to 3 g of x. Now you know over here 2 multiplied by what? It'll be 3. Minus, it will be again minus 2. So this will be 6 plus 4, 6 plus 2, answer must be 8. So the final answer will be 8. Same way you can solve these. These are one of the easiest type of problems. Now they have given the same thing, just that the function is minus over here. So split the integral sign. It'll be 3 minus of minus 2 will be plus. And over here, same thing. Just solve them directly. You can't use them directly in calculator because there are functions. You need to apply the limit, distribute the limit inside. Constant, just keep it out. Apply the conditions, what they are mentioned, and then solve it up. The 20th topic is also on definite integrals. Now, over here, definite integrals means you will know the limits. So limits are known. So whenever limits are known, that means definite integral problems can be solved and calculated directly. But now if you see the problems over here, it's all complicated. So over here it's 5. You can easily use the calculator. But what about this and this? I'll tell you a method to use the calculator. All you need to do is type in as it is integral alpha x into root x plus, sorry, that is alpha x over here, plus 3 divided by x. Now, the limits are from 1 to 4. and press equal to, you will get some answer which is not there in the options. So it's 16.558. Okay, it'll be 9 anyways. So now over here, okay, now there's one more thing. What is the answer for 3 divided by x? So it's a confusion. In some places you can see log. Log means base 10, whereas natural logarithm is base e. So this is a difference. So if you put log, you will not get the answer. Wherever there is log, if at all there is log in your option, I guess they might give you ln itself, but if at all there is log, it's fine. Just don't put log, just put lan over here. Instead of log, put lan. Now, this was the answer using calculator, because the calculator definition is not log, it will always be ln. Okay, even the computer softwares, most of the time they'll consider 1 by x as 3 ln, sorry, lan, len, or natural logarithm x. Okay, so now what we will do is we will just put this, solve this in the calculator. So it'll be 62 divided by 5 plus 3. Don't put log, put ln 4, and the answer will be the same. The matching answer, the 4 options, right? Only one option will match, and that will be your correct answer. So this is the thing. Okay, you can try this all by yourselves. Now, even over here, let me just do this integral. It is 6 into e. That is, how do you get this e? Don't press alpha and over here. That means you can get e, but you won't get the power. Then you need to do it like this. You can do that, but easiest method is shift and ln. That is e. Minus 3 alpha x. Now plus 4. Over here it is 0, and up over here it is 1. And press equal to, you'll get the answer. Now it's not matching. I'll just keep in mind 5.9. Let me solve all the values. 2, it's minus 2 divided by e to the power 3 plus 6. Sorry, plus 6 is over here, the fraction. Now it should be 5.9, and that's the correct answer. So always remember one thing. You can do it by integrating. You can integrate it and apply the limit. It's the same thing, but it's just going to take you lots of time. Whereas doing it in calculator and checking for the answer will be much easier. Now over here, it's the same thing. All problems are very straightforward, but just remember when you have trig functions, let me do this last one. When we have trig functions, 2 sine alpha x, that is alpha, okay, it's alpha x, close the bracket, minus cos x. And now you put the value pi by 2, that is shift and pi divided by 2, 2 pi, isn't it? Now just be careful with one thing. If I press equal to now, I'll not get the correct answer. I need to make it in radian mode, that is to shift, mode, and 4. Only now I'll get the correct answer, that is 3. So please make sure any trigonometric function you have to have radian mode on. Now if you're thinking how will you put CSC, cosecant, it's not there, right? Remember 1 by sine is cosecant, okay? Whereas 1 by cos is secant. So you need to use that. Over here for tan as well, cot as well, you need to put 1 by tan and then solve it, and then you will get the answer. Same way you can try all the others, but you won't get the answer like this. You will get it in a decimal way. You need to just check the answers later on. Please try them by yourself. Whichever method, if you like to drive, you can drive it and then try. However, try it and then check the answers. Over here, all the answers have been solved and shown. Okay, one thing over here. Okay, it's good that I just scrolled down here. Now, these cases you cannot do direct calculator method. Why? Because over here the terms are unknown. See, it's definite integral, but t unknown value is given. So if it is this case, see, generally they have given a simple problem over here. I'll just solve this quickly. E to the power x by 2 is half, and you're squaring this. That means basically you're multiplying the power by 2. Cancels. What is e to the power x derivative? It is now over here e to the power x itself. So derive e to the power x, sorry, integrate over here and apply the limits. Upper limit is t, lower limit is 0. How do you apply the limits? It's always upper limit minus the lower limit. So e to the power t minus e to the power 0. Anything raised to the power 0 is 1, so you will have e to the power t minus 1. This is this method. Now over here, likewise, sine square x plus cos square x is equal to 1. That is a standard formula which we must remember always. So now this dissolves to 1. Integrate this 0 to t dx. The integration of a constant will be x. Now constant v is 1x and the t to 0. So now I'll just use the upper limit. It'll be, sorry, not power. It'll just, x will be turned, instead of x, you have to put the upper limit t. Minus 0 will be 0. So it'll be only t. So this is how we solve it. I hope this are clear. So do try other problems as well and check the answers. This topic is to solve integrals by substitution. The substitution method is also called as U substitution because, over here in this method, you take a complicated term and substitute as U. That's why the name U substitution. Now, before we start this, look at this problem equation. This is a very hard problem to solve by simple integral, whatever we have learned till now. So now, to make this less complicated, we do this substitution. Basically, we are manipulating this equation, integrating, and then getting back to the original. Like whatever we have assumed, we are putting it back. Let us see how we are doing. Now, assuming the value for u is not a constant. See, it depends on each question. So you need to solve more and more problems on this to get a better understanding. But whenever you have e to the power something, it's better. See, this is a complicated term. Put it as u. And it must be so taken that the other factors also will be eliminated. Let's see this now. See, eu. Now, sorry, I'll take it u equals square root x. Now, I've considered this term as u. But remember, if I have integral of, say I'll take a simple term, x square, I'll have dx over here. Same way, if I have integral of m square, I'll have dm. Now, if I have integral of u square, I should have du, isn't it? If I'm substituting u over here, I should integrate with respect to u, so this will be du. So what do we do? So that is why we need to differentiate this and get du. But it won't be just du, it'll be du by dx. Sorry. Because we are differentiating with respect to x equals, this formula for root x is 1 by 2 root x. This is it. Now what do we do? You need dx, so keep dx at one side, okay? And other things to the other side. 2 root x over here, du will be equal to dx. Now substitute this and this back to the given equation. Then you can see it will be simplified. Integral of root x is u divided by root x dx is basically, sorry, instead of dx we write 2 root x du. Now you can see there are terms that cancels, this cancels with this, and now 2 is a constant, take it out, integral of eu du. Isn't it so simple to solve the integral of eu? Now we'll do it. The integration of exponential anything will be same thing. It is u itself, but plus c. This is not over. Don't forget we had taken u as root x as u, sorry. For simplification, it will be simpler to solve. Now put it back. E root x plus c. So this is the real actual final answer. So you can see the final answer would be, so 2e root x plus c. This e is correct, eu, but remember we had substituted root x as u, so substitute back. That is the final answer. Similarly, you can solve the others. It is just that you need to take the appropriate value to substitute. Then it is basic integration. So let us just look into the values over here. See, whenever you have cos, it's easier you take this. And when you take this, even the other values get eliminated. The questions will be so given that you should take one u value and then the term gets reduced. So now over here, you have 1 by x as u. So what happens is when you differentiate this, it'll be minus 1 by x square, and then rearrange to get dx. This goes out the side and it becomes minus, and then you can simplify it. See, root x cancels, and this minus sign prevails. Integration of cos u will be sine positive sine u, but this minus sign will be there. But don't forget to substitute back what was u. 1 by x was substituted as u, so put 1 by x back. That's how we solve it. Please do solve the other problems as well. Now over here, it's inside root, right? Because when we had e to the power square root x, we took this entire term as u because it's much simpler. But now don't take this as u, just take the inside term. Why? Because when you derive this, you're going to get this part, isn't it? X to the power 3, which will cancel off. See, you just have to substitute u as x to the power 4 plus 3, derive it, you will get du is equal to so much, but you need to have only dx. So what happens is dx equals du divided by 4x cube. So whenever you change this dx to du, it will be divided by 4x cube. Hence, this cancels and you will have a simplified form. Now, you can see the steps over here. U is x to the power 4 plus 3. This is very important. Derive this, get dx. Substitute everything back over here. It will be square root u, but a square root is taken as half, and this cancels, and 1 by 4 is written out, constant. Integrate this by adding plus 1 and divide by plus 1, and you can easily get the answer. So don't see, this is the answer, yes, but don't forget to substitute whatever you took as u. So this is the final answer. Same way over here, this is similar. Whatever is inside, substitute as u. See, over here when you integrate, it'll be just number, so that's fine, and you'll just get a constant. Over here now, see, again, see, it's better to take whatever is inside. You can't take sine because it'll be more complicated, because it's easier to solve root u. Why? Because you know how to solve that. Whereas if it was sine x, if you had taken u divided by root u, very much complication. Though you can solve it, it's better to take u, whatever is inside the square root. So in this case, we take cos as u value and then derive, substitute and do the same thing. Same way over here. Now over here, it's not the same thing. It's see, you need to understand thoroughly, because there is sine cube. If you take sine cube over here as you derive it, you will get a complicated term. You can't do it. Now, if you take cos also, you won't be able to solve properly. So what do? You're taking sine from here. See, take sine as u. Derive this. What will happen? When you derive, you will get cos dx. So now just take this cos to the other side. I will just do this once again. U is equal to sine x. Du by dx is equal to cos x. Okay, differentiation of sine is positive cos. Now what is dx? Dx is equal to du by cos x. Now let me substitute everything back. See, sine I have taken as u. So how many sine is there? 3. Sine to the power u to the power 3 into cos x. And now I have du by cos x. So this cos x cancels. You have only u to the power 3 du to integrate now. Isn't it easy now? U to the power 3 du. Integrated, you will get the answer. Substitute back the sign. That's it. So please go through all the u values. See, and u values whenever it's inside sine or cos. See, this is generally taken as u. Even over here, this will be generally taken as u. Only this, not the power, only whatever is inside. So once you know the u values, it's pretty straightforward. Now, we have done similar problem, e to the power. So whatever is there in the power, we take it as u, for only for the e thing. Now, in this case, see, don't take x as u. If you take x, you can't solve it, Because there is square root, you need to take whatever is inside square root. This entire term is taken u, and then you can simplify and solve it. So I can't tell you exact method, though there are some baselines. It depends on the problem and it differs as well. So try to solve more problems and you will easily understand. So over here we had done this initially. Square root x was u, and over here whatever was inside cos. Please do the other problems by yourselves and then check for the answers. The 22nd topic is similar to the 21st topic, so please watch the previous video before coming over here. Now, the last video, it was direct problems. But you must remember, whenever they ask you substitution method to solve integral, they must give you the values such that you will be easily, you can solve it by substituting. In the sense, if you consider the substitution of u of a particular thing, the other values must cancel off. Otherwise, you cannot solve it. So it will be designed in such a way that you will be able to solve it. Okay. Now let's look at this problem. If you have seen the last video, your obvious guess would be to take whatever inside the square root as u. So what is inside square root? 1 minus x to the power 4. So I have to take u as that one. Now what will be du? Du is minus 4x to the power 3 dx, and over here take keep dx and take everything else to the other side. It will be du divided by minus 4x cubed. Now this is dx. But look over here. If I put this as dx over here, back over here, so it will be x divided by square root u. Now what? Dx is du by minus, I'll remove out, and 4x cubed. X cancels with over here, it will be square, but I have x square remaining. I can't solve this because there are two different terms and two different see, now du means I have to integrate with respect to u. Now again x is there, it's an entire different term. So now what do we do? It's not possible. Whereas over here in this second problem, it was x to the power 3. So this cancels off. Okay, it's fine. I can easily solve it. Okay, minus 1 by 4 is constant. Integral 1 by root u du. This is fine. We have done such problem before. So this is very simple. This is it. The substitution becomes. But what about the first one? In such problems, when I look at this, there is no way. See, there's a jump over here. It's power 1, there is power 4. There is no way I can derive this and get over here. So you need to do some modifications to the question. X, let it be square root 1 minus. When I say the square root, I remember sine inverse. Sine inverse x. What is the integral of 1 by square root 1 minus x square? That is sine inverse x. So how about instead of x, I write x to the power 2, the whole power square. This is the same thing. It is x square, the whole square. Now this is what I will try to do. So now over here, don't take 1 minus u square and all as u. Just take u equals x to the power 2 and then substitute. Let us see over here. The methods are there, steps are there. Here, I've taken u as x square. So that over here, this is substituted. And now it will be dx will be du by 2x. X divided by root of 1 minus u square. Then du by 2x. So why 2x over here from the dx? Now all you need to do is cancel this off and you're remaining with half du by root of 1 minus u square, that is sine inverse u. Don't forget to substitute what is the u value, that is x square. That is it. The second one we just now solved at the beginning. So if you've missed it, just pause it and go back to the little minutes before of this video and you will find it. Now it is also another simple thing. Over here, we just did this substitution and everything. We got negative 1 by 4 integral root 1 by root u. This is power half, right? They have taken it up. So it'll be u minus half du. Now easily solve it and you will get the answer. So this is how you can easily solve them. See now over here as well again, just make sure you do see there's a jump Over here it is fine. If I take u as 1 plus x square, I'll get the answer. That's it. U substitution, very simple. But in this case, it's not that. I need to rearrange 1 plus x 3 the whole square. Why? Because if I only derive x to the power 3, I'm going to get x to the power 2 up. So make sure it is x to the power 3. Okay, I'm so sorry about this. There is an error over here. X to the power 3 and power 2. I will edit this and I will upload it again online in the link where you download the presentation. Sorry, this is power 2. Okay, that is an error. So now you need to substitute u as x to the power 3, and then du will be 3x squared dx, and so on. Dx will be du by 3x squared. Now substitute x squared divided by 1 plus x to the power 3 is u, so it will be u whole square. What about dx? It will be du divided by 3x squared. This is very important. X square and x square cancels off, and then you're getting 1 by 3, this constant, take it out, du by 1 plus u square. You know 1 plus u square is tan inverse x. That's it. But don't forget to substitute the u value back over here. That is the final answer. Plus c is very important because it's integrals. And now the next one, you don't need to worry much. It is just 1 plus x square, and then you can substitute. We have done such problems already in the previous videos. Now we will go to this type of problem because it is little different. Now imagine, see, now what I would generally think is, okay, I will take this as 1 plus x squared as u. Let me derive this. U is equal to 1 goes off, it'll be 2x. But now over here in the numerator, you don't have 2x, it's 1 plus x. Such problems, you know, in the numerator, you must have x plus x to the power 3 by 3. Only if you have this, then you can get the above term when you solve, isn't it? Sorry, it is x power 2. Uh, yeah, x power. Okay, sorry, this is the thing, x power 2 by 2. Now, I mean, what I mean is if the denominator was such, then when I derive this, it'll be 1 plus 2x divided by 2 is x. Now it will be 1 plus x. So only if the denominator was x plus x square, I could have got this. Now it's not like that. I'm getting 2x. It's not possible. What would you do? I can't take this because you try in exam, if you get this problem, you might generally try the denominator and then you'll be stuck. So it's a good thing. You'll be stuck. That means you have to change something. Go back to the problem. See, this is a special type. You need to modify the question. Now, instead of having the denominator everywhere, I'll do this. 1 plus x squared plus x divided by 1 plus x squared. Now it's easier. See, left side I know. What is this? 1 plus x, 1 integral of, okay, it should be dx and dx everywhere in both the sides. Now, integral of 1 by 1 plus x square is tan inverse x. Tan inverse x. So that is very simple. Just remaining the right side, you need to do substitution method. So over here, I will consider u to be 1 plus x square. Now it's fine because du will be 2x dx, and dx would be du by 2x. That is dx. So now I can easily substitute over here, isn't it? X as it is, over here it is u, and dx is du by 2x. Now this x and x cancels, and then I can do the substitution only for right side. Let me just show you. You're splitting these terms because if I add 1 by 1 plus x square with x by 1 plus x square, I'm going to get 1 plus x divided by the common denominators. So that's why we split it out now, and then left side is directly integral, that is tan inverse. Left side I can do directly. But right side I need to do the u substitution, which we just now saw, and you will be having, when you do the u substitution, this cancels with the below, and this will be du and this will be u. So it will be du by u. That's it. Oh, sorry. The 2 will be there, okay? Because x square, right? It will be divided by 2x, x cancels, half will be removed out, du by u. And we know 1 by u is natural logarithm u. Now please don't go to take this up and solve. See, don't do like this, u to the power minus 1, because when you use power rule, it will be undefined. Whenever it is 1 by u, it is natural logarithm magnitude of u. So it's 1 by x. Integral is always ln x magnitude of x, because natural logarithm cannot be negative. Now the right side is more simpler. Now over here over here the answer will be after you substitute whatever you assume to be u. The b value, see now this one, b question. You can see over here it's minus. That means you have the formula, that is a squared minus b squared. What is the formula? It is a plus b, a minus b. Same way, use the formula over here. What happens? 1 can be written as 1 squared, so 1 plus x, 1 minus x. Now solve it up. This cancels because it's multiplication. Over here it was plus everywhere. You couldn't cancel it directly. I can't cancel it. And I can't split this because there is no formula to split it. This I can. So cancels over here. And what is remaining? 1 by 1 plus x. Now this is pretty easy, isn't it? Take u as 1 minus x, and du will be minus dx. Or why is this? I'll just derive it. Du equals minus x dA. Sorry, I have done this error. Over here it is minus 1 dx. Minus 1 is just minus sign. Take this to the other side. It will be minus du equals dx. Now substitute back over here. Instead of dx, I'll put minus du divided by u. So minus sign can be removed out. Du by u is 1 by u, basically. Integral of 1 by u is ln u magnitude. So the answer will be that. So this is the final answer, minus ln. Sorry, I have integrated it. So that will go, it will be plus c. So ln minus ln u plus c, but remember to substitute whatever is u, that is we assumed. Same way you can solve. See, these are all simple problems which are done previously. Now over here, see, you can see this one, if you take it as u, square root u plus 1. What happens when you derive? You will get du 1 by 2 root x, isn't it? So this is dx. So this will go up 2 root x. We have done similar problem in the last video. Du is equal to dx. So when we change this, okay, I'm so sorry because over here they have given u. So you do not substitute u, you need to substitute some other term. It can be t, x, y. Over here it's t, that's why t, okay, dt. And this is given values are u, okay. So now all we need to do is dt, everything in terms of t, okay. This will be root u. Du will be this. I hope you're getting my point, just that the variable over here is changed. Du. So now instead of du, you need to substitute 2 root u dt. And this root to u and root u cancels. You're remaining with 2 constant, 1 by t dt. Now you can easily integrate it. So make sure you just remember which is the u substitution, the substituting integral. So this will be substitution. Over here it's denominator because it's just whenever you derive it, you'll get up above. Same way, easy problem. Go through all this, very, very straightforward. But look over here, you can't solve this directly. You need to use sine by cos. Tan is sine by cos. Sine 2x, cos 2x. Now, this is it. Now you can easily do the u substitution for the denominator and then derive it and do it. All the methods are solved over here. Please make sure you go through them. Everything is very, very simple. Now over here in this case, they have taken u as sine inverse because you can see when you derive that you will get this term. That means this cancels. So it will be simplified. See, it will be just u to the power 3 when you integrate it. And then you will have u to the power 4 by 4. U is sine inverse. Similarly over here, again, similar problems. We had solved this. Just make sure we had solved it at the beginning. X squared the whole square. So the same problem repeated. Please solve all of these by yourselves and then check for the answers. They are pretty straightforward. Just remember, if sometimes you cannot solve, you need to manipulate the question and then solve it. Now we move on to the 23rd topic, which is coming under the part 3. Hence, this will be writing. 23rd, 24th, and 25th topics are writing. And now this topic is about optimization, real world problems on optimization. Now let's see the problem. A three-sided fence is built next to a straight section of a river which forms the fourth side of a rectangular region. The enclosed area is equal to 1800 feet square. Find the minimum perimeter and the dimension of the corresponding enclosure. So now they are telling a river is passing by. Now imagine this the river and a fence is done. Okay, a fence, enclosed area. Now you must understand the fence won't be all the three regions. Why? Because one side is the water, so you don't cover that. Only three-sided region. So that's what it's mentioned even over here. Three-sided region. Now let us assume few things. Let's consider length to be y, width to be x. Okay. And now the area is also given, that is 1800 feet square. Now, see over here, very important in such problem, related rates problem, optimization problem, that which they have asked to find minimum or maximum. It's the perimeter over here. So if it's the perimeter, you need to derive perimeter. If they mention area, then you have to derive area. Now, in this particular thing, let us derive perimeter. So keep it for the second time because derivation is later, right? First, find the area. Area is length into breadth. Area is given 1800. Length and width is xy. So we usually keep in terms of y. So write y is equal to in one side and all the other thing to the other side. This is the thing. Now, which is the quantity that needs to be optimized? In this case, it's minimum, so it's minimized. That is perimeter. That is only three-sided. Now let's see, it will be y plus 2x plus x, that is y plus 2 times width. So that is p is equal to y plus 2x. Now we know over here y was written in terms of x, right? Substitute everything like that. Now p with respect to x will be, instead of y, 1800x plus 2x. Now look over here. This is very important. X is greater than 0. Can it be less than 0? No, it's obviously it's a real world thing. You can't have dimension 0 or less than 0. So that's why we have this. Now, can we estimate the maximum? No, we cannot, because anything greater than 0 can be possible, but we will get an optimum region dimension in a while. So now for this particular problem, this is the perimeter equation. Now what do you have to do is differentiate this, because let us find the critical values. Now this is critical values is what we have seen in the previous videos, the initial videos, critical value, finding increasing, decreasing functions. The same thing will be employed over here. Derive this. It is, see, this is a constant. This area is constant. It will be 1 by x. Derivative of 1 by x is minus 1 by x square dy by dx, okay, or derivative or dash y dash. So you will have minus, instead of 1 we had 1800 divided by x square plus, now 2x is there, this x goes off, it will be 1, so it is only 2. Then we need to equate the perimeter, derivative of the perimeter to 0 to find the critical numbers, and just equate it to 0 and solve for it. Now how it is done over here, wait, let me just show you. See, this part is going to the other side of the equal to, it becomes positive. Okay, it will be 1800, positive 1800 by x square. Then the division of x square, take it to the other side, will become 2x square. And now divide 1800 by 2 and you will get, okay, it's over here, directly done in calculator, but it's fine. You can do it like this. Divide both the sides by 2. You will have 900 over here, and square root x square will be 900. Square root of 900, of 3 is 9 is 3, so it will be 30. 30 plus or minus. See, always remember when we take square root, we'll have plus and minus. Now, what about this? Minus cannot be the dimension because it cannot be negative, isn't it? It's always greater than 0. So this is the dimension. Now, x is 30, but is it the minimum value? How do we understand that? So now there are many ways to do it. Not many, there are only a couple of ways. So now one thing, critical value is 30, so we can write this and take a test value, which we have done before. So less than 30, greater than 0. I'll take 1. Why 1? Because it's easy to calculate, isn't it? So minus 1800 divided by 1 plus 2. Obviously, this is dominating, the value will be negative. Over here this is negative, okay? And then take more than 30, because we know over here when you square it, uh, anything more than 30 will be more than 900, so it will be less than 2, so it will be positive value. You can put it in calculator. If you're getting confused, take 31 or 40 or anything, you will get the same answer. Now that means we have negative decreasing and increasing, so the graph is something like this. We have a minimum point, so we get a minimum point over here. Or there is one more method, if you remember, before we had done this, using second derivative. So if you can derive this again, just do the second derivative of this. You will get this over here, 3600 divided by x square. How do you do that? Take x square up, it becomes negative power, and then solve it up. So over here you got this. And then now what do you do? Apply the critical values. Put the critical value instead of x and solve. Over here you can see the value is positive, greater than 0. That means if double derivative and applying the critical number, if it's a positive value, it's concaving up. So what do you have over here in the parabola? Minimum value. So it will be absolute minimum 30. Okay, so we wanted minimum perimeter itself. So the length is x is equal to 30 feet. Then we can find the width because we know it's 1800 divided by x. So width is 60 feet. So this is how we can easily solve the problem. Sorry. I hope you understand this. It's all these steps. Now we'll go to the next problem as well, because this is a little bit different. Now over here they have asked to maximize volume, but the question is little tricky. A box with no top is built by taking a 6-inch by 10-inch sheet of cardboard, cutting x in squares out at each corner and folding up at the sides. Find the x that maximizes the volume. Okay, what it means is, now imagine you have a square like this. Okay, now, you might have remembered you might have tried this before. You can't make a proper box if the ends are there, the corners are there. So what you must do is you must remove these corners out, take them out, and then this can be folded and made into a box. Okay, so that is what they are saying over here. This is the dimension 10 by 6 inches, 6 by 10 inches, sorry. But you need to remove the squares over here. So how much will be that? That is x, right? You're removing x. So this is x over here. But in same side, there'll be two x's. Same thing over here and over here. And it goes on. So the dimension instead of 6 becomes 6 minus 2x, and instead of 10 becomes 10 minus 2x. So this is your length and the width. And the height over here is given to be x. That's the for the volume. Now you know all the three dimension. You can just, now it's very simple like what we have done before. So I'll quickly go through this. Volume means multiplying everything. Just write it as it is. And then over here, this is interesting. I mean, not interesting, it's important. The domain. Obviously, volume can't be less than 0, so it will be always greater than 0. But what about this maximum value? Now, there are two dimensions over here, isn't it? Let's find what is the maximum value this can have. So, this must be greater than 0. Why? Because it can't be less than 0. Greater than or equal to 0. Now, find the x value. Take this to the other side, it will be 10 greater than or equal to 2x. X must be less than or equal to 5. Okay, this means x is less than or equal to 5. but we have not written 3. Why is that? See, this is the bigger dimension. You need to take this other dimension limit as well. See the domain for that. 6 minus 2x must be greater than or equal to 0. So take the 2x to the other side. It will be 6 must be greater than or equal to 2x, or 3 must be greater than or equal to x, or x must be less than or equal to 3. So this is how we get the domain. Okay, so that is important. And now we know, we can just multiply this inside, and we know how to derive. We have to derive and find the critical value equating to 0. Do it in calculator, you'll directly get the answers. Now over here, look, there are two values. One is exceeding the limit of 3, and one is below this, below, yes, within the limit. So take the one which is within the limit, and you can solve. Yeah, that is the critical value. But over here, remember, since it's volume, we have to take all the endpoints. Since it's I mean, this is a there's a condition given over here. It's not like last time, not x and y. You can X and y can be anything more than 0. No, it's not like that. Over here, there is a limiting factor, because this cannot be negative, so it must be greater than or equal to 0, right? In the last case, there was no x like this, no minus, right? So it could have been greater than 0 over. But here there is a limiting factor. So take the endpoints as well. Take the endpoints and put it in the volume equation over here, the main equation, okay? Substitute over here. Instead of x, put the endpoints, that is 0, 3, and also the critical number. Check where you get a maximum value. It will mostly will be in the critical number, and that is the maximum volume. So now if you have maximum volume, then you can continue with the, you can easily solve for the x. Oh, x was already done, so that's it. Sorry, if you have maximum volume, you can find the length and everything, because maximum volume is found. Sorry, you have the critical number x, that is the x value to be considered. So substitute in these and you will get the answers. Height is same, but length and width will vary. That's it. So please do try the other problems. They are very, very similar. They are very, very similar. All the explanation is there, but I'll just quickly go through one of this. I'll just quickly go. See, this is also same, easy. You can easily try this. Okay. Now I'll just tell you a little bit about this. They have told show the rectangle of maximum area for a given perimeter. Now over here, they have told the perimeter is constant, right? A given perimeter. So we'll consider area equation, perimeter equation. For a rectangle, area is xy, perimeter is 2x plus 2y. Now get everything in terms of y. So take everything to the other side and you'll get this equation. Put this back in the area equation and derive it, okay? And then you derive this. Once when we derive, what happens is you will get this. How? Try this, because we have done problems like that before. It is through the product rule, u dash v plus uv dash. You can check this, and this is the equation. Now simplify this. You will get like this, and take this 2x to the other side and simplify. You will get p is equal to 4x, or x is equal to p by 4. Now this is done. Over here, the limit, see, x must be greater than 0, and what, it should not be negative, so it must be less than within this value, because this is the maximum value, right? It must be greater but less than that. If it is greater than that, the area will be negative, see, less than 0. So the limit is always 0 within this range. Now the thing is, so maximum p by 4 is perimeter is so much, x value, sorry, is p by 4. So now substitute the other side. What is y? X we know. Y will be p by 2 minus x, and you will get again a p by 4. So over here you're just substituting p by 4. Now that tells us the dimensions are same. That means it's a square. For a particular perimeter, for a given perimeter, this will become a square, because if you derive and solve it up over here, the dimension of the x and the y considered will be same. So please do go through all the problems solved over here and check your answers by yourself after you solve it. We are back to the 24th problem. Now, here we need to solve real world problems of indefinite integrals. Before we begin, I want to tell you about few things, that is acceleration, velocity, position. It is very important for you to know integral of acceleration is velocity, whereas integral of velocity is position. Now, in this particular problems, you will either be given acceleration or velocity. You need to solve for position function. Let us directly start solving this because this is an easy problem. Given as the function, velocity function, and then you have got the initial position. But you need to find the position function with respect to t. That is s of t. You will come to know in a while how easy it is. But before that, remember integration of what is what. Now, integration of velocity is position. So all I need to do is integrate this v of t. That will be equal to what? Integration of v of t. 3t minus 12t square by 2 plus c. I have done integration. 3 nothing is there, so it's t minus 12t square by 2 plus c. Don't forget the c is very important. Now I'll just simplify this and write it'll be 3t minus 6, sorry, not 12, minus 6t square plus c, and this is basically the position function s of t. Now this is a crucial thing to remember over here. The position s of 0 is given. That means if I have s of 0, what will happen with the t values? It will be 0. So this becomes 0 minus 6. This becomes also 0 square plus c. What is that equal to? It is equal to 3. See, they have told the position when this all this function is where t is 0 means the 0th time at the initial point where time is just starting 0 time, the initial position that means is 3 meters. So put the function over here, everything wherever t is there, put 0 and solve for the constant. Now, since it's a polynomial function over here, just t, right? Whenever you multiply, it will just become 0. Sorry, over here, see, it when you put 0, it will just become 0. So whatever is this value remains, that is c is equal to 3. So the final answer is this, but instead of c, you write 3. Let us see over here. This is the answer. How do we do? Integral of velocity, that gives you this answer, 3t minus 6t square plus c. Then what you have to do is substitute the initial position, that is t as 0, and solve for c, because we know the final answer would be 3, and then we get c is equal to 3, and this is the final answer. Similarly, we have one more problem where acceleration is given. Now it is the same thing. I'll just solve it very quickly over here. But over here sign is there. So remember, be careful when you substitute these initial points. Now integral of acceleration will be equal to 3 cos. See, now I forgot the minus sign will be minus cos, okay? Sine integral is minus cos t plus t equal plus c, sorry. This is the thing. Now this integral a of t means it is v of t, okay? V of t. Now let me put this t as 0, and wherever there is t, I have to put 0 plus 0 plus c equals, what is the initial velocity? It's 0. But now look over here. What is cos 0? Put your you can try it in your calculator. If you know the graph of cos, see, sine starts from 0 0, but cos starts from 1. So the value of cos 0 is 1. So minus 3 into 1 plus c is equal to 0. Take this to the other side, c is equal to plus 3. This is the answer for velocity. Now this is the equation, minus 3 cos t plus 3 is the answer. Let us see the written over here. See what happens? Minus 3 cos t plus 3. So this is the velocity position. Now we did just now in the last problem from velocity to position. Same thing will be repeated now. From velocity, you can find the position by integrating the velocity. It'll be minus 3 integral of cos t. Integration of cos t is just sine t. So minus 3 will remain sine t over here t squared by 2, 3t plus c. Now again you need to put everywhere wherever t is there 0. See now sine t sine 0 is 0, this is 0, this is 0. So c value will be equal to 4. So the final answer over here will be minus 3 sine t plus t squared by 2 plus 3t plus 4. That is it. That is the position function. Now that is straightforward. Please make sure you solve the remaining problems by yourself. Very simple integrals, and that's it. And then check with the answers over here. All the answers are solved. Now we will quickly go to the last problem, the 49th. There are two problems over here. This is interesting because they have told you sketch the graphs of two function, the function that is f of x. We must graph the function, but they have given us the derivative. See now this is a derivative, that is f dash function. We need to find the normal function. So now imagine you have been told the derivative f dash of x is x cubed. This is the function. It's x cubic graph, right? And it's up by 2, so I'll write plus 2. Now, how do you find the function? Integrate it. Integrate f dash of x. You will get f of x. Isn't it? The function will be obtained. Now, integration of this would be x to the power 3 plus 1 is 4 by 4 plus 2x plus c. We don't mind the constant. It can be anything. It's fine. So this part is important. Now, it is very hard for me to graph x to the power 4 plus 2x. How would you graph it? You know, this also, see, I don't know, there might be anything. This c can be 1, 2, 3, anything. It can be, see the graph, whatever I draw, if it's x to the power 4, it might be like this, or it might go up like this, something like this, or like this. It can be anywhere. The vertical shift, I mean, up, going up or down, even it can go down like this, anywhere up or down. So what it means is I won't be able to draw the exact graph, but I will be able to tell you how does it look. Now, how does it look? This is the derivative, isn't it? F dash of x. So remember in the first chapter, in the initial lessons, the video number 1, 2, 3 and all, initially, we were finding the critical values. That is, the derivative f dash of x was made equal to 0. And then we found the critical values. Why? Because at the critical values there was maximum or minimum values, isn't it? Maximum or minimum. So over here now you don't have this graph. Try to ignore this graph, think it's not there. So this is somewhere at 2.4, isn't it? So at 2.4, over here critical value will be there. So I will have either a minimum point or a maximum point. I don't know the graph, that's why I'm just assuming it will be up or down over here. Okay, but how would I know it's a maximum or minimum? It's simple. You can see there's only one critical point, isn't it? So there is only one over here in the answer, minimum. It won't be two. So you must know there is only one critical point at minus 2.4. Okay. Now, we used to do that, like this. We used to take the critical point, say 3, minus 3 or 0, and then we used to find whether it's positive or negative value. In f dash, if it is negative value, that means it's decreasing. So now look over here, critical value is obtained. This is either minimum or maximum because I don't know the graph, right? How will I know? How will I know which is maximum, minimum? It's very simple. See if the graph below this intercept over here is below the x-axis or above the x-axis. It is below. If it is below the x-axis, then what? If it is below the x-axis, then the function will be decreasing over there till that. So what you have to do is an exam, you will have like this, right? At negative 2.4, you must draw somewhere any, you won't know the exact value, but somewhere over here, and just draw. Because it's the minimum, right? Don't do it up over here. If you do it up, then everything will be shifted upwards. You can do it because anywhere it's correct, it will be vertical shift. It's a your graph will not be same like the others graphs. Okay, now what you need to do is, all you need to do is make decreasing. So this is decreasing. Okay, next, look at the right side. Is it Increasing, is it positive values? Yes, it is positive values, isn't it? So then what I do is I just do increasing. But this is not correct. Why? Because in this particular case there is no other values, but just make sure over here it is passing through y-axis, and this is not a quadratic. It is not quadratic to be curved. Look, this is cubic, right? That means this is x to the power 4. So draw this point, and then wherever the f dash of x is 0, over here this passes through the center, this point over here. Okay, then you can just like have some inclinations like this. See, it's like just some, modulation, that's it. Not the exact one, this is the approximate graph. Because since it is, if you wait, I'll just tell you why you should not do like this. This means it's parabola x to the power 2. Look, the derivative is x to the power 3. That means the function must be x to the power 4. So really x to the power 4 graphs will be something like this. So that is why you draw it, and it's approximate. Just tell that, this is a cubic graph. This will be around x to the power 4 graph, and then below this point everything is decreasing, over here it is increasing. That's it. That is the main things you can do, and this is approximate graph. There is no correct answer. There are many correct answer. That's the thing. Okay. Um, and over here, see now one more thing. Look, if you see, there is all these dips and all. This is just for extra thing. Now, wherever there is change in this angle, see, there is the inclinations. So what I'm trying to say is, you can see over here there is concaving down, concaving up. So those all things can be done in detail, which we have done in the previous lessons. So that and all is there, but basic graph is fine. So that is the thing. Over here, it's the same thing. Now you have been given the derivative. So derivative is given. What is the function then? Now over here, see, this is a constant, right? This is a constant. That means there was a straight linear graph somewhere, all these points. See, at this point, it is linear, and this point also it's a linear. Now since it's a step, it is going up, then over here it is parabola. So over here it is like this, and then over here this is a not a, this is a straight line, and from this point again it's a straight line. Why? It's linear. So just understand that these are all the functions. If you integrate this, what will you get? Now over here you will get cubic, right? If you integrate this, you will get cube. This is a constant number 1. When you integrate this, you'll just get x. So this is the one. And look over here, there is no values below over here. So ultimately, this is just increasing. See, it's going upwards. See, there is no critical values over here. So you can match these. So this is the graphing part. It can be, many graphs can be the same answer, but this is very important because that is the objective we have mentioned about, indefinite integrals. So be thorough with this, and graphing is pretty easy because many graphs can be the same answers. We are in the 25th topic, which is the last topic in your end of term exam syllabus. So this will be the writing topic, the last writing topic in your part 3. There are 2 more writing topics, which are the bonus questions, which can be anything that we learned throughout the term. So now over here, this is on related rates. It's all application questions. You need to understand the question thoroughly, and then you need to try to make a figure and then solve the problem. Now, over here, they have asked, suppose a 6 feet tall person is moving away from 18 feet lamppost, and the person moving away from the lamppost is at a rate of 2 feet per second. What is the rate of in the length of the shadow that is changing? Now, we should understand by a figure. Now, this is a figure. A huge lamppost is there. This guy is the person. Now, the shadow, see, this is the light that is falling, and the shadow is somewhere over here. He is moving at a rate of 2 feet per second. What exactly does that mean? Now, over here, since it's related rates, we differentiate with respect to time. It's implicit differentiation over here. So now this is x, right? Length. It is dx by dt. Okay, that is given to be 2 seconds. Why? Because the rate of change, That is the thing, okay? They did not give you the length. They did not tell the length x is something. No, it is dx by dt. It is very important to understand. Now, dx by dt or x dash value is given to be 2 feet per second. Now, what do we need to find? The rate of changing in the shadow. So now this figure helps us to find it out. There are many ways to solve it, but the easiest way is to know this is, to compare the related parts of the triangle. Now, this over here, this would be similar triangles, isn't it? Over here and over here. Since they are sharing sides, it'll be a similar triangle. Now, from the parts of the similar triangle can be written like this: 18 divided by 6 will be equal to, now this is the big length. So what is the big length over here? X is the distance from lamppost to the person, and S is the shadow. The total length will be X plus S. And what is the small triangle length? That is only S. So now you can rearrange this and write everything in terms of X. You need to find the derivative of X. So take everything to the other side, keep X at one side. You can do it like this. Say, now 18 divided by 6 can be simplified to be 3 equals 3 over here. I'll take this s to the other side, it'll be 3s equals x plus s. And take this s to the other side, it'll be 3s minus s, 2s equals x. Or x is equal to 2s. That is how we can get it. Or there is another way, that is using tan theta. You know, tan theta is opposite by adjacent. So 18 divided by x plus s. Same way over here, the angle is same, isn't it? 16 divided by s. These can be equated and the answer will be same, whichever method you do. See, the answer is x is equal to 2s. They are writing everything in terms of t because it's related rates. Now differentiate this. Now, since there are two functions, implicit differentiation, what happens over here? X dash only. Here 2 is constant, S dash. That's it. So differentiation is straightforward. Now substitute the values back. Which is the value known? 2 feet per second. So substitute over here 2 feet per second. That is 2. Over here is 2. So rearrange and write S dash would be 1 feet per second. Now, since he's going that side away, it'll be positive. So it is increasing by a rate of 1 feet per second. As is going, the shadow is increasing. So this is how we solve this problem. We will see one more problem over here. Sand is poured into a conical pile with the height of pile equaling the diameter of the pile. If the sand is poured at a constant rate of 5 meter cube per second, at what rate is the height of the pile increasing when the height is 2 meter? Now, what this means is, let's understand this in a figure. This is very important. The height of pile is equaling the diameter. Now, this is a conical pile and sand is being poured. So the volume of the sand is keeping on increasing. See, now this is the base, this is the radius. The height is the diameter, that is d. We know radius is equal to diameter by 2, or 2 radius is equal to diameter, right? This is given, but it is not d, that is h, because they have told height is equal to diameter. This is important, okay? And then they have told us the sand is poured, the rate of pouring is 5 meter cube per second, and the rate, at what rate the height of the pile is increasing when the height is 2 meters. That means when the height is 2 meter, what is the uh, height increasing? The rate of height must be solved. We will see now one by one. The given values are over here. Height h, radius is h by 2, which we just saw. Why? Because h is the diameter. Now, dV by the change in the volume, that means the constant rate of pouring, right? The change in the volume is 5 meter cube per second. It's increasing by 5 meter cube per second. We need to find the rate of change of height dH by dt at the height of 2 meter. We just don't want the value. We need to find it at this particular instant. We will see now. So over here, what is the shape? It's a conical shape. So volume of the cone is given by 1 by 3 pi r square h. So you must remember this formula. Sometimes it might be given, but in this case it's not given. So you must know this formula. And now you know what is V, right? V equals 1 by 3 pi r square h. You know dV by dt. So derive this differentiation. But before differentiation, sorry, you can't do like with all this V unknown, R unknown, H unknown. No. Try to get implicit differentiation means you need to have two variables, right? So just rearrange this R and write in terms of H. What I mean is, we know R is h by 2, isn't it? Given in the question. Height equals the diameter. So instead of R, write h by 2 and the square. See, like this. Now what happens is h by 2 the whole square. Now over here you can square both the sides. Square both. H square divided by 2 square is 4. And now rearrange this and write. Over here it will be 1 by 12 pi h cube t. So now this is the volume, rate of change of volume in terms of h. Okay, it's h cube. Why? Because you squared both the sides, you multiplied h over here 1 by 12, multiply 3 and 4. 3 and 4. Now this is the rate of change of volume with respect to, this is the volume with respect to time. I'm so sorry. It's the volume, it's not the rate of change. We need to find the rate of change of volume by differentiation. It'll be v dash h dash. So what do you do? dv by dt equals pi by 12. Now this is the constants we are removing out. Now this will be done by chain rule. First do for the 3, that is 3 comes down, h square t, and then derive the ht function, that is dh by dt. So now this is what we have done from the conical formula, deriving it. So you know the conical formula is volume of the cone is V equal 1 by 3 pi r square h. What you need to apply is, instead of radius, write everything in terms of h, the height, and then solve it, simplify it. Now derive both the sides implicitly with respect to time. We get this. Now that means we know many things, right? V dash we know, that is phi. Now substitute everything back. Now this is just simplification over here. 3 and 12 cancels out to be pi by 4. H square, h dash is this. Now we need to just substitute over here. That is dv by dt is phi, and h over here is known. H they have told we need to find the rate of height at what? At height of 2 meters. So all we need to do is phi by 4. H will be 2. So 2 square into h dash. This h dash is what we need to solve for. Take everything to the other side. Just take everything to the other side. Solve it. It'll be 1.59 meter per second. So the rate, the height is increasing by 1.59 meter per second when the height is 2 meters. So this is how we can solve it up. Now everything will be given. You need to substitute and solve it. This was done just a while ago. Now over here there is a part B question. What they have asked over here is basically, if the person is walking in the other direction, so he's walking towards the lamp, and the rate has also changed 3 feet, same like what was done over here, sorry, same like what was done over here, just that this rate of change will be minus because he's coming in the opposite direction. So that's why it's minus. Okay, so all you need to do is x dash is how much over here? Minus 3, same like what we had seen in the first problem, but it'll be minus 3 by 2, or 1.5 feet per second, negative because this is in the opposite direction. So this direction matters. And over here we have about Boyd's law. This is again a simple one. I'll just tell you briefly. There's a formula given, PV is equal to C, that is Boyle's law, and then pressure, that's about pressure, volume. Now P is the pressure, V is the volume, and C is the constant. Now what you need to do is, they have asked you to derive pressure, rate of change of pressure divided by rate of change of volume must be equal to this. You have the formula, isn't it? Just derive it. P will be P dash. Now this, oh sorry, you need to use the the product rule. U dash V plus U V dash. So you can, or you can use this first over here, U V dash plus u dash v. Okay, this whichever can be used. Over here, this is used, the second version. P is written as it is, derive v plus derive p and multiply by v equals 0. Now over here, you are just rearranging and getting towards, get the p dash over here. See, keep this over here as it is, take the other terms to the other side. So what happens is p dash t, I'll just write p dash, and v equals minus p into v dash. Get v dash to the other side and take this to the other side. P dash divided by v dash equals minus p divided by v. Now, this is okay. This is the pressure divided by the volume. What do we have to write it in terms of? C and V. So V, let it be. In the denominator, it's fine. But what is P over here? P is C divided by V, isn't it? So just instead of this P, put C divided by V. You're substituting, it'll be minus C by V squared. So that is the answer with respect to time. So that's what we have got. Similarly, you can try the next one. Over here, again, they have told about, again, differentiation. Just the same thing what we have done. See, compare. Now over here you need to find, derive p dash with respect to volume. So what this means is, now function f of x, now you are 1 by x. What is the answer? You derive this minus 1 by x square, right? Same way they have told, differentiate pressure, differentiate this with respect to volume. Sorry, differentiate this with respect to volume. This is constant, but this will be derived and you will have to solve. It'll be same thing. See, minus c by v square, like minus 1 by x square, but v is the derivative, and this will be just p dash v. And then compare the answers. The answers will be the same thing. See, that's what. Similarly, please do try the other problems. Now, over here, the figure is given, but the figure won't be given in the exam. You need to do the figure. And then now over here, you have to use Pythagoras theorem and solve it up. Similarly, you can try the other problems. Just make sure you understand, go through it properly. And depending on the shapes, now here it's conical shape, use the cone. If it's spherical, use the sphere, and solve them by yourself and check for the answers.